The sun's light has always been the measure of all life, steady, omnipotent, divine. For billions of years, it has burned with a rhythm older than memory, exhaling storms of fire into the void. But in the winter of one unremarkable year, a disturbance rippled across the solar wind, a flare, magnificent and violent, like a dragon's breath spilling across the black. Astronomers turned their instruments toward it, their sensors trembling with the electric pulse of a living star. Yet, something in that outburst defied understanding. For just an instant, as the flare surged outward in a tide of plasma and light, something intercepted it, something small, silent, moving where no planet, no rock, no human machine should be. The data was fleeting, a dark signature cutting across the blaze, a shadow that fed. The flare's brightness dipped, not from obstruction, but from consumption. The plasma seemed to vanish, devoured by an unseen mouth in space. And when the brightness returned, it bore a wound, a gap in energy that could not be explained. The sun had lost a piece of itself, and in that loss, something foreign was born. Telescopes around the world began to whisper the same story. An object, faint and fast, emerging from the flare's wake, trailing nothing but heat ghosts. Its motion was erratic, its orbit non-Newtonian. It was as though the very laws of celestial mechanics bent around its will. It glimmered in the data just a few photons, a curve of acceleration, and then a pulse of reflected fire that did not match any known albedo. The astronomers gave it a name, a sterile label, 3I Atlas, the third officially recognized interstellar object to enter our solar system, but the name could not contain the unease it carried. Because 3I Atlas had fed on the Sunday, the story leaked in fragments, observatory reports buried in conference notes, anomalous readings from magnetometers, a sudden uptick in radio silence from teams that usually shared everything. Some dismissed it as an instrument glitch, others as wishful thinking, another echo of the Oumuamua hysteria. Yet a few saw something deeper, something that trembled against the edge of comprehension, the possibility that matter itself had learned to eat light. The solar flare in question was not extraordinary, a typical Class X outburst, enough to cause geomagnetic storms, but nothing apocalyptic. What made it infamous was the subtraction. Energy left the sun that never returned to the spectrum. The physics of it made no sense. Nothing can simply disappear from the energy budget of a star, yet here it had. Weeks later, the faint signature of 3I Atlas emerged from that same region, faintly glowing in wavelengths that corresponded to superheated ion clouds. Its spectrum whispered of iron, silicon, carbon, but twisted by something else, something refracting beyond atomic familiarity. It was small, perhaps 100 meters long, tumbling through the darkness with a rhythm too steady to be random. It reflected sunlight, but imperfectly, like a broken mirror learning how to shine. The public never knew of the flare connection, not yet. Those who did were silent. Space agencies convened in encrypted channels, unsure whether they had witnessed a natural miracle or a cosmic trespass. Was 3I Atlas merely coincidence, a wandering relic crossing paths with our star, or had it come for the sun? In the first images, it appeared almost shy, a dim speck, barely traceable against the dark, but its silence spoke louder than its glow. Every known celestial body moves with a predictable grace, shaped by gravity's ancient pull. 3I Atlas did not obey. Its trajectory was not curved by the sun, it leaned into it, as if tasting the warmth, as if drawn not by mass, but by hunger. That hunger would become the question of a generation. If the sun can be fed upon, then energy itself can be stolen, and if energy can be stolen, then somewhere, something might be feeding on the light of countless stars. And so begins the chronicle of the most forbidden mystery in modern astronomy, the day the sun was bitten, and a nameless traveler accelerated away with a piece of its soul. For most telescopes, space is a predictable sea, the slow dance of rocks, dust, and light. But when the Atlas Survey telescope in Hawaii first caught the faint glimmer, now known as 3I Atlas, the night itself seemed to pause. The automated terrestrial impact last alert system, a network of robotic eyes designed to find deadly asteroids before they find us, was never meant to discover visitors from other stars. Its duty was terrestrial, vigilant, almost routine. Yet on a quiet shift in early December, one of its arrays caught a wandering light with no discernible origin. It was dim, erratic, tumbling through a pattern that defied the calm choreography of the solar system. Most detections are swiftly identified: a leftover comet, a passing rock, a trick of reflection. But this one did not fit. Its parallax motion was too quick, its apparent brightness inconsistent. Atlas's algorithms hesitated before classifying it at all, and by the time human eyes reviewed the alert, the object had already moved beyond the comfortable predictability of near-Earth space. The coordinates placed it somewhere beyond the orbit of Mars, gliding against the faint haze of the zodiacal light. But it was not merely gliding, it was shifting, adjusting, almost as though responding to invisible tides. Astronomers cross-checked with Pan-STARRS, with the Catalina Sky Survey, with orbit determination software that had tracked 1,000 comets. The residuals, the tiny differences between predicted motion and observed motion, refused to shrink. Something was pushing 3I Atlas. In the control rooms of Haleakala, the technicians leaned toward the data feed in silence. The object was small, barely resolvable, but consistent. It reflected enough light to measure rotation, and from that rotation, something even stranger emerged: periodic flashes that did not correspond to sunlight alone. The glint was too narrow in bandwidth, as though its surface polarized the light, sorting it, choosing which wavelengths to throw back. The Atlas team tagged the object formally: 3I Atlas, the third interstellar visitor after Borisov and the infamous Oumuamua. But something about the classification felt hollow. The earlier interstellar objects had drifted predictably, obeying gravity, trailing faint debris. This one was quiet. Too quiet. There were no sublimation jets, no dust tail, no thermal glow of melting ice. It was sterile, and yet alive with motion. Within days, the coordinates circulated through the minor planet center, and astronomers worldwide turned their lenses to it. Amateur astrophotographers in Chile and Spain tried to catch its faint trail, but most failed. It was too dim, too transient. Only the largest instruments could see it clearly, and even then, it danced on the edge of detection. When data from Atlas's sister observatory in South Africa came through, the picture sharpened. The light curve revealed a distinct pattern, a rotation period of just over 8 hours, with brightness peaks that rose and fell irregularly. It seemed to twist its body toward the sun, then away again, like a flower caught between hunger and fear. The discovery came during what should have been an ordinary week of sky scanning, another line of data in humanity's endless effort to catalogue the heavens. Yet beneath that routine, something uncanny unfolded. Observers noticed that the object had appeared near the remnants of a recent solar flare, a flare whose afterglow had barely faded from the heliospheric data maps. That flare had been catalogued, measured, dismissed. But now, tracing the coordinates backward through time, astronomers realized that the flare's trajectory and the object's path intersected precisely down to the second. Coincidence, some said, statistical overlap. But deep in the Atlas archives, the timestamps told another story. The moment the solar flare erupted, sensors registered a minute and unexplainable drop in expected brightness. A piece of the sun's fury had vanished into the dark, and seconds later, at the periphery of that eruption, something had appeared. From that instant onward, the light curve of 3I Atlas began to grow. In the control rooms, the hum of computers seemed louder than usual. The scientists whispered in low tones, reluctant to name what they were seeing. A cosmic coincidence, yes, but also something else, a rhythm, a relationship between flare and form. When plotted across days, the trajectory of 3I Atlas curved slightly, leaning inward toward the sun as though drawn by appetite. It absorbed photons greedily, its thermal signature rising, even when it should have been cooling. It was, by every standard of astrophysics, impossible. Still, the protocols demanded calm. Every object gets a classification, every anomaly a rational line of text. Interstellar object, non-gravitational acceleration suspected, the report read. But outside, as the winds brushed across the summit of Haleakala, the night sky shimmered with indifference. Somewhere in that infinite silence, a small object drifted toward the sun, carrying with it a secret no equation had yet dared to write. And far below, the data scientists could not help but feel that they were no longer observers, but witnesses that they had glimpsed something ancient in a modern sky. They named it 3I Atlas because science demands order even from chaos. The naming conventions for interstellar visitors are clean, almost clinical numbers and letters replacing awe with bureaucracy. But within those sterile syllables, a tremor of unease lingered. The I stood for interstellar, and the 3 marked its place in a growing lineage of wanderers that had crossed our solar system from beyond the Milky Way's familiar breath. Yet this one carried a shadow that none of its predecessors had. When it first appeared in the Atlas system, its signature was so faint that for hours it lived as a rumor. Only after a second pass confirmed its motion did it earn official recognition. A designation, a file, a placeholder in human knowledge. But as with all great cosmic stories, the act of naming was only the illusion of understanding. In the quiet of observatories across the globe, scientists began their ritual, compiling the object's light curve, estimating its size, projecting its path. At first, it looked harmless small, no larger than a modest asteroid. Its trajectory was hyperbolic, meaning it would never return once it left. These were the comforting facts. They made the mystery measurable, but comfort rarely survives contact with truth. When the first official orbital calculations came in from JPL's Solar System Dynamics Group, something was already off. The object's inbound velocity was higher than expected for debris entering from the local interstellar flow. That alone was unusual, but not impossible. The troubling part was its acceleration, a persistent, directional increase in speed that refused to fit any known model. Objects in space obey gravity. Always. The laws of Newton and Einstein may bend under extreme conditions, but they do not simply disappear. Yet 3I Atlas behaved as if it were feeling a wind that no one else could feel, a hidden current blowing through the vacuum itself. The Atlas detection team did what scientists always do when the universe misbehaves. They question themselves first. Calibration errors, data artifacts, optical illusions, there are always ghosts in the machines. They reran the models, checked for stray reflections from the detector housing, cross-verified with multiple observatories. But every dataset told the same story. 3I Atlas was moving too fast, changing speed too often, and doing so with a precision that seemed intentional. Soon, other observatories joined in. Pan-STARRS from Hawaii, Gemini North, Subaru, the European Southern Observatory in Chile. Each new instrument painted the same haunting portrait, an object of uncertain form, spinning slowly through the sunlight, growing brighter when it should have dimmed, and shifting its trajectory without visible propulsion. As data accumulated, Its path through the solar system was plotted in color-coded arcs, beautiful, deceptive lines that traced a dance through planetary space. It came in steep, dipped near Mercury's orbit, then curved outward, brushing the inner rim of the asteroid belt. It did not collide with anything, did not fragment, did not behave like a comet shedding gas or dust. Its albedo, its reflective brightness was constant, except when it wasn't. At irregular intervals, it would flare briefly, as though illuminated from within. NASA's Minor Planet Center released an official circular acknowledging the anomaly. It was measured, composed, cautious. Unexplained, non-gravitational acceleration observed. Further study warranted. But between the lines, a quiet panic settled in, because everyone remembered the last time they'd written something similar back in 2017 for Oumuamua. That first interstellar visitor had been a revelation, a thin, tumbling shard of rock or metal, or something else accelerating as though pushed by invisible hands. The explanations back then had been pragmatic, perhaps hydrogen outgassing, perhaps a fragment of cometary ice. Yet no model fit the data completely. The mystery faded only because the object itself did, vanishing into the cold dark beyond Jupiter's reach. But 3I Atlas was worse. Where Oumuamua had reflected sunlight passively, 3I Atlas seemed to react to it. Its acceleration correlated with solar flux. The more light it absorbed, the faster it moved. This was not a passive drift. It was an active conversion. Something on its surface or within it was transforming radiation into motion. If that was true, it meant one of two things. Either 3I Atlas was a natural object possessing a material property unknown to science, or it was built. The whispers began to spread, cautious and coded. Some in the astrophysics community began to call it the Eater, a joke, at first dark humor shared over midnight coffee and flickering screens. But the name stuck, because somewhere deep down, they all felt the same tremor. 3I Atlas had come through the sun's fire unscathed, and it was not leaving quietly. In the data vaults of the Atlas project, archived readings from the solar flare weeks prior began to surface again. Someone noticed the correlation, the overlap between the flare's peak emission and the object's sudden brightening. They ran the numbers, recalibrated the timestamps. It fit too perfectly to ignore. And then, in a single late-night email that would quietly ripple across the global astrophysics network, an astronomer from the Solar Dynamics Observatory wrote, "It's as if it fed on the flare." No one replied. Not officially. For now, the object remained just a dataset, a streak of light, a list of numbers, an unresolved question written in photons. But within that silence, an ancient fear began to take root. Perhaps the void was not as empty as it seemed. Perhaps it was watching back. And somewhere beyond the orbit of Mars, a small object drifted on, its vector slowly changing, its brightness pulsing like a heartbeat in the dark. The moment of feeding it was brief, almost imperceptible, like the blink of a cosmic eye. The solar flare that birthed the mystery erupted from active region AR3427, a storm of charged particles unleashed into space with the fury of 10 billion hydrogen bombs. For most of its lifespan, it behaved exactly as expected. The flare's energy surged, peaked, and began to decay, until, for precisely 4.6 seconds, something unnatural happened. At 8 hours, 47 minutes and 32 seconds UTC, the flare's brightness across multiple wavelengths, visible, ultraviolet, and X-ray dipped sharply, as though an unseen veil passed through the plasma. The drop was narrow but absolute. Instruments aboard the Solar Dynamics Observatory captured the anomaly in exquisite detail, unaware at first of its significance. The region of the flare that dimmed did not cool, nor did it disperse. It simply vanished, its radiation absorbed by something that had no right to be there. Later, when teams reprocessed the data, they would discover a faint echo, a spectral afterglow in the 200–250 nanometer range displaced from the flare's center, a delayed burst, as if some external surface had caught the sun's energy, then released it imperfectly, with a strange delay. For those who knew how to read such signals, it was a signature of interaction, a conversation between the sun and an intruder. And in that moment, a mystery older than science itself seemed to awaken. The solar flare, to the untrained eye, was chaos plasma twisted into arcs by magnetic fury. But beneath that chaos lies structure. Each burst follows magnetic field lines shaped by the sun's rotation, a geometry of light sculpted by mathematics. The flare's plasma loops expanded outward, pushing through the corona, until one of those loops appeared to bend, pulled sideways by a force not of solar origin. Astronomers replayed the footage countless times. They adjusted filters, recalibrated baselines, verified calibration dark frames. The same anomaly persisted. A pocket of plasma, abruptly compressed and redirected, then extinguished, as if it had collided with an invisible wall, or worse, been drained by it. At that precise moment, 1.8 million kilometers away from the solar surface, the faintest optical echo appeared in data from Atlas's survey feed, a moving speck emerging from the glare. The timelines matched within seconds. 3I Atlas was born in the wake of that vanishing energy. The story would later be reconstructed from thousands of fragments, solar magnetometer readings, coronagraph footage, radio flux anomalies, and heliophysics simulations. When combined, they told a narrative both coherent and terrifying. The sun had lost a measurable fraction of its flare energy, and that loss coincided perfectly with the appearance of a foreign body. Physicists struggled to define it in their language. Energy cannot simply disappear, it must transfer, radiate, or dissipate. Yet here, it had neither radiated nor scattered. The missing power had not been absorbed by dust or reflected into space. It had gone somewhere. A few dared to whisper the phrase no one wanted to print, energy sink. Could 3I Atlas possess the ability to absorb electromagnetic radiation directly to drink the sun's fury and transmute it into motion? The thought was absurd, the stuff of speculative cosmology or science fiction. And yet the numbers were unforgiving. The sun's flare had dimmed by 0.003%, an almost unnoticeable deviation, except that the missing energy was equivalent to the yearly consumption of all human civilization, multiplied 1,000,000 times. To have taken even a fraction of that meant that 3I Atlas was not a passive wanderer. It was active, selective, purposeful. Weeks later, as the heliophysics community revisited the flare, they found corroboration in the magnetic field data. Instruments aboard the Solar and Heliospheric Observatory, SOHO, detected a disturbance in the interplanetary magnetic field, propagating outward a pulse that did not match any coronal mass ejection pattern. Its shape was too coherent, its decay too slow. The waveform hinted at reflection, as if the flare's energy had met something solid, or at least organized. And at the center of that reflection lay a mystery of motion, 3I Atlas, accelerating outward. For those who first noticed the pattern, disbelief quickly gave way to dread, because if an object could interact with a solar flare in this way, it meant it had harnessed control over plasma fields of unimaginable density, the very breath of a star. In the days that followed, heliophysicists from multiple agencies ran their models in secret. What they found was worse than speculation. When they fed the data into simulations, the flare's magnetic topology appeared to fold inward at the site of the anomaly, as though space itself had curved. That curvature propagated outward, a subtle distortion traveling along the solar wind, invisible to the naked eye, but measurable to the most sensitive instruments. It was as if the sun had been momentarily bitten and the wound had healed before anyone could see the teeth. There were no press releases, no headlines, just silence and a sudden increase in encrypted data transfers between NASA's Goddard Space Flight Center, the European Space Agency, and Japan's JAXA Heliophysics Division. They were not trying to explain what happened. They were trying to confirm that it did happen. One astrophysicist, years later, would describe the event with quiet reverence. "We saw something that turned the sun into prey." That sentence would never appear in print, but among those who studied the flare, the feeling was unanimous. Something extraordinary had crossed into our system, something that did not reflect light, but fed upon it. And if the sun could be devoured, even for an instant, then what of all the other stars we have never seen dim, never heard scream across the black ocean of time? In the aftermath of the flare, the sun's surface seemed to hum with residual tension, like an instrument still vibrating after the bow has passed. The corona, the sun's ghostly outer veil, shimmered unevenly, ripples of magnetism fanning outward as if trying to erase what had happened. But there were traces that refused to fade. Instruments aboard multiple solar observatories began to register strange harmonics in the solar wind, pulses of charged particles that did not match the usual pattern of expansion and decay. These ripples were not random. They were rhythmic. They pulsed outward every few minutes, synchronized to a pattern that no natural flare aftermath had ever shown. The magnetometers aboard SOHO and ACE recorded the anomaly first slight oscillations in the magnetic field intensity, as though something invisible were dragging the solar wind into its wake. Then came the readings from the Parker Solar Probe, orbiting closer to the inferno than any human-made object before it. Parker's data revealed an even more disturbing feature, a series of rapid, repeating compressions in the local plasma density, forming what scientists called microshock fronts. Normally, such disturbances would be the dying breath of a coronal mass ejection, but this event had no CME. The flare had not thrown its material into space, it had lost it, as if something had absorbed the ejection before it could escape. And whatever caused those microshocks seemed to be moving, pulling the solar wind behind it in a long, invisible tail. Heliophysicists began to notice correlations. Each pulse in the magnetic field corresponded precisely to the growing distance of 3I Atlas from the Sunday. The intervals between them stretched as the object accelerated outward, like a heartbeat slowing as it moves away. It was as though the sun itself were remembering the encounter, whispering its aftershock into the solar system, pulse by pulse. The solar wind, normally chaotic and diffusive, now showed traces of coherence, fine filaments of magnetic alignment, converging toward the same outbound vector as 3I Atlas. Some called it coincidence, others resonance. But in the dark corners of research labs, whispers began. The object took something with it. It wasn't mass, not in any conventional sense. The sun's mass loss rate from solar wind and flares is well understood. But energy, specifically magnetic energy, seemed to have bled from the corona into some unknown sink. Models of the heliospheric current sheet, the great undulating plane of magnetic influence that fills the solar system, began to show small discontinuities along the object's projected path. It was as if space itself had been briefly scarred. In Japan, data analysts at JAXA's Hinode Observatory noticed something uncanny. The flare's aftermath left a thin, bright streak across ultraviolet imagery, but within that streak, an absence, a faint, needle-like void that traced directly outward from the Sunday. When enhanced, it resembled the wake of a boat cutting through water, a vacuum trail through plasma. It led, with unnerving precision, toward 3I Atlas's projected course. The idea began to take shape in speculative papers that would never pass peer review, that the object was not merely passing through the solar wind, but feeding upon it, metabolizing charged particles, magnetic fields, and radiation into kinetic motion. But how? The sun's plasma is chaotic, turbulent, impossible to harness without immense control over electromagnetic force. Even the most advanced human technologies, fusion reactors, particle traps, struggle to maintain plasma for seconds. Yet this object had done so effortlessly in the middle of the solar inferno, without disintegrating, without deceleration. Some physicists proposed that 3I Atlas possessed a naturally resonant magnetic shell, a configuration that allowed it to convert electromagnetic flux into momentum, much like a photon sail, but using magnetic induction instead of light pressure. But such a structure would require a coherence field, a stability in plasma confinement that bordered on intelligent design. Others leaned toward darker speculation. The object's interaction with the flare, its pulse-correlated acceleration, its apparent control over local plasma flow, it all suggested an active system. Perhaps 3I Atlas was not an inert mass at all, but a mechanism, something that maintained itself by drinking from stars. If that were true, then the patterns in the solar wind were not random scars, but signatures of digestion. Weeks passed. The sun calmed, but the solar wind did not. Magnetometers across the inner solar system continued to detect fluctuations aligned with 3 Atlas's path. The oscillations grew fainter with distance, but they never disappeared completely. It was as if the object had left behind an echo, a silent wake trailing back to its feeding ground. Astrophysicists quietly renamed the event within their own notes, the solar wound of 2025, a poetic name for something they could not explain. The wound would never fully heal. The sun's next few flares showed slight irregularities, missing energy here, an asymmetric outburst there. The magnetosphere seemed restless, remembering the visitor's touch. And while the world carried on, unaware beneath its fragile blue veil, the scientists who studied the data could not forget. They had seen something that did not merely pass through the solar system, it interacted with it. It had fed, and the evidence of that hunger now whispered through every gust of solar wind, every pulse of the sun's restless breath. For the first time in human history, the sun had not been the predator, it had been the prey. At first, the data seemed to mock them. Every trajectory model, every simulation, every gravitational calculation collapsed into contradiction. No matter how carefully they plotted the motion of 3I Atlas, the outcome refused to obey the laws of Newtonian mechanics. The equations themselves, sacred to the architecture of celestial order, buckled under a truth they were never meant to hold. The object was accelerating. Acceleration in space is not an accident. For an interstellar body drifting through the void, momentum is destiny. It is a relic of its creation, locked forever, unless altered by external force, gravity, impact, or radiation pressure. But 3I Atlas defied this covenant. When its outbound velocity was first estimated from optical data, the numbers were startling but not impossible. Yet, days later, as additional observations poured in from Chile, Spain, and South Africa, its speed had increased. By the following week, it had gained more than 50 meters per second. And the acceleration was not random, it was directional, coherent, and aligned perfectly with the vector of the sun's radiative flux. Solar radiation pressure alone could not explain it. Even the most optimistic models, assuming a thin reflective surface, failed by several orders of magnitude. Nor could sublimation, the outgassing of ice from a cometary body. There was no tail, no spectral evidence of water or carbon dioxide, no halo of dust. 3. I Atlas remained geometrically precise, smooth, almost surgical in its refusal to conform to nature's mess. It was as though an invisible hand had pressed against its back. The official term, coined in an internal ESA memorandum, was non-gravitational propulsion signature, but outside official channels, another name circulated, whispered through late-night video calls and encrypted emails among physicists, the impossible acceleration. The effect was first confirmed by triangulated data from the Subaru telescope and Gemini North, which observed the object over consecutive nights. When they compared positional data to gravitational models, the residuals were undeniable. 3I Atlas was deviating from its expected path by measurable amounts each day, as though accelerating from within. Dr. Lena Kovacs, an orbital mechanic at ESA's Space Situational Awareness Office, spent sleepless nights recalculating. She used everything: relativity corrections, solar flux variations, even Yarkovsky thermal recoil effects. Nothing could account for it. "It's not drifting," she whispered to a colleague after the fourth revision. "It's deciding." That phrase, though poetic, captured the mood. For every scientist trained to separate observation from superstition, the implication was unbearable. The cosmos was meant to be indifferent, its motion mechanical, but 3I Atlas was not indifferent. It was dynamic, purposeful, responsive to light. And then came the telemetry from NASA's NEOWISE satellite. While observing in infrared, NEOWISE detected an anomalous temperature distribution. One hemisphere of 3I Atlas was significantly hotter than the other by over 80 degrees Kelvin. Such asymmetry was impossible unless there was controlled absorption of energy. The object appeared to be harvesting solar radiation, storing it and expelling it directionally. Suddenly, theories poured in. Could it be a hollow structure, an ultra-thin sail of unknown material accelerating through photon momentum, or perhaps a crystalline body with internal refractive layering designed to trap and release energy? Yet none of those ideas explained its resilience during the flare event. No known material could have survived that inferno, let alone fed upon it. One speculative report, buried in an arXiv draft that would never be published, proposed something radical. If 3I Atlas is accelerating without exhaust and without losing mass, it must be drawing upon field energy, possibly magnetically induced thrust via vacuum polarization. In other words, a machine operating on the fabric of spacetime itself. For weeks, the astrophysics community lived in oscillation between wonder and fear. If 3I Atlas was a natural phenomenon, then physics was incomplete. If it wasn't, then humanity was not alone. Neither possibility was comforting. By the third month of observation, the object's velocity exceeded the escape speed of the solar system by a wide margin. Yet even as it sped away, its trajectory curved slightly not outward into interstellar space, but inward again, as if tracing a long elliptical arc. The models showed a gravitational impossibility, a body accelerating toward the sun despite outward velocity. It was as if it were locked in a feedback loop of light and motion, drawing nourishment, then gliding outward to digest it. A metaphor spread quietly through the halls of astrophysics institutes. It's breathing. Breathe in, absorb the flare, accelerate outward. Breathe out slow, cool, curve back inward, awaiting the next eruption. The sun had become its heart, beating once every solar pulse. Those who studied it began to see the cosmos differently. Stars were no longer eternal furnaces burning alone in the void. They were potential sources, hosts to unknown parasites or mechanisms. How many suns across the galaxy, they wondered, dimmed slightly for reasons we never noticed? How many flares had been eaten? How many pulses swallowed in silence? If 3 I-Atlas was real, measurable proof that energy could be consumed without combustion, then it was also proof of something far older, far hungrier than humanity. In a late-night internal memo at NASA's Jet Propulsion Laboratory, one line appeared beneath the data logs. "If this continues, we are not observing a comet. We are witnessing a process. And if that process had a name, no one dared to speak it yet." The comparisons began quietly whispered first in the corners of astrophysics conferences, then surfacing in draft papers and encrypted message threads. The name that kept returning was one already carved into the modern mythology of astronomy: Oumuamua. For those who had lived through its discovery, 2017 felt like a warning unheeded. A cigar-shaped visitor from interstellar space, tumbling silently through our solar system, accelerating without exhaust or explanation. Oumuamua had challenged the comfort of known physics and then slipped away before humanity could decide what it truly was. Comet? Asteroid? Alien probe? Every theory had failed to fit neatly. And now, almost a decade later, another traveler, 3I Atlas, had arrived to reopen the wound. But this time, the similarities went deeper than coincidence. Both objects shared the same hallmarks of impossibility: a hyperbolic trajectory, non-gravitational acceleration, and spectral silence. Yet where Oumuamua had reflected sunlight erratically, 3I Atlas seemed to absorb it, converting radiation into thrust. The difference between them was not of kind, but of behavior. One had mirrored the sun, the other had fed on it. Comparing their data sets became an obsession. Teams in Hawaii, Chile, and Arizona dug through the archives of Oumuamua's light curves, revisiting its faint glimmers with new suspicion. Perhaps, they thought, the signs had been there all along. Perhaps that first visitor had not merely reflected light, but stored it a primitive version of what 3I Atlas was now perfecting. It was an irresistible narrative: the first scout, the second evolution. Oumuamua's mystery had once inspired the work of Harvard astronomer Avi Loeb, who famously suggested it might have been an artificial probe, a light sail sent by another civilization. His proposal had been met with equal parts fascination and ridicule. Yet now, in the shadow of 3I Atlas, his words gained a grim new resonance. If one anomaly is a fluke, two begin to sketch a pattern. In a closed meeting between NASA, ESA, and the SETI Institute, the question was raised with unsettling calm. If Oumuamua was the first, and Atlas is the second, how many more are there? The thought was unbearable. For decades, humanity had looked outward in search of company. But what if that company had already been here, not as emissaries, but as harvesters? Both objects shared an uncanny silence. No radio emissions, no thermal noise beyond what their surfaces absorbed, no signatures of propulsion or communication. The void between their signals was not emptiness, it was restraint, as though they knew how to hide within physics itself. 3I Atlas differed, however, in one crucial respect. It was responsive. Its motion changed with the sun's activity. When solar flux increased, so did its acceleration. When the sun quieted, it drifted. That correlation was undeniable. And when physicists overlaid the timelines of the solar flare, the one it had seemingly consumed, and its subsequent acceleration curve, the graphs aligned perfectly. The conclusion was devastatingly simple. 3I Atlas did not merely use sunlight for propulsion. It fed upon the sun's energy directly, perhaps through electromagnetic induction, perhaps through mechanisms beyond human imagination. By this point, telescopes across the planet were fixated on it. The Very Large Telescope in Chile, Keck Observatory in Hawaii, and ALMA joined the chase. Data piled up, infrared readings that hinted at a metallic sheen, polarization patterns that defied standard models of reflection, and a spectral absorption line in the near ultraviolet that corresponded to no known element. The object's surface was smooth unnaturally so. Not the weathered chaos of a rock, not the pitted ice of a comet, but something precise, perhaps even engineered. Under polarized light, it shimmered in gradients rather than glints, as though composed of layers tuned to manipulate photons themselves. Scientists compared its albedo to Oumuamua's and found the latter dull, ancient, the rough prototype of a concept perfected. In a private communication that would later be leaked, one astronomer wrote, "If Oumuamua was a seed, Atlas is the bloom." But perhaps the most haunting similarity between them was not their movement, but their intentionality. Both had entered the solar system from trajectories inconsistent with random interstellar drift. They seemed guided, their vectors intersecting not by chance, but by design. One passed through the inner system, then left. The other entered, lingered, and turned inward again. The difference between the two felt almost biological, as if one had been reconnaissance and the other predation. To many, it was still coincidence. Coincidences, after all, are the language of the cosmos. But beneath that rational comfort, unease was spreading, because if both objects were part of a pattern, if the universe had built or birthed travelers that consume starlight, then perhaps this was not an isolated event, but an ancient mechanism woven into the galactic fabric itself. A pattern so vast that even stars might fear it. In one late-night session at the Harvard-Smithsonian Center for Astrophysics, a researcher pulled up a list of stellar dimming anomalies collected by Kepler, years earlier stars that flickered unpredictably, their brightness dropping without explanation. One name stood out, Tabby's star. Its erratic dimming had once inspired theories of alien megastructures, Dyson spheres, and cosmic architecture. All dismissed, all forgotten. But as she compared the light curves Tabby's star, Oumuamua 3I Atlas, the rhythm felt eerily familiar. The dips were not random, they pulsed, almost like breathing. She whispered into the dark, to no one but herself. What if they've been feeding everywhere? In that moment, the universe no longer seemed vast and indifferent. It seemed alive, but not in any form humanity had imagined. By the time global observatories coordinated their focus, 3I Atlas had already become the most studied object in the solar system. Telescopes that once hunted exoplanets now turned inward, their lenses drawn to the faint, flickering enigma gliding between Mars and the asteroid belt. It was no longer the curiosity of a single team, it had become an event, a celestial obsession. The European Southern Observatory, Keck, Subaru, ALMA, Hubble, and dozens of smaller ground-based facilities formed a worldwide network of synchronized eyes. Together, they attempted to create a continuous timeline of the object's behavior, a 24-hour watch on something that refused to stand still. For the first time in human history, the entire scientific world aligned its gaze upon a single point of light, and still, it slipped through understanding like a dream. Every night brought new contradictions. In one hemisphere, the object's albedo appeared to increase as though a reflective surface were blooming across its skin. In the other, it dimmed, the light swallowed by something that wasn't shadow but absorption. When plotted against the sun's activity cycle, a pattern emerged. Each time the solar wind intensified, 3I Atlas responded like a living thing, brightening, rotating, accelerating. At ALMA, radio astronomers noticed faint ripples in the background static, a narrow-band resonance near 1,420 MHz, the famous hydrogen line used in deep space communication. The signal wasn't transmitted, exactly, it wasn't deliberate modulation, but rather a byproduct, a hum in the background as though the object's interaction with the interplanetary medium created electromagnetic echoes. They weren't messages, not in the human sense. They were reaction, and reactions implied a process. Meanwhile, the James Webb Space Telescope, operating from its stable perch at L2, captured infrared data unlike anything seen before. Webb spectrometers detected fluctuations in the mid-IR spectrum, suggesting rapid heat redistribution across the object's surface. In ordinary comets or asteroids, this would indicate thermal lag heat slowly moving through rock or dust. But in 3I Atlas, the pattern was too fast. Heat moved across its form in waves, rippling like fluid over metal. When converted into a thermal map, the image resembled something almost biological: filamentary currents, regions of heat clustered along a lattice of invisible veins. The comparison was purely metaphorical, of course, but those who studied it could not unsee the resemblance. Across continents and time zones, data analysts compared notes. Each discovery bred more questions. The Hubble Space Telescope registered micro-variations in its rotation rate, tiny fluctuations, as though the object were making deliberate corrections to its spin. Keck's adaptive optics revealed minute structural asymmetries, shapes that shifted subtly over time. And in the background of every observation, one fact grew undeniable. It was responding to the sun, not gravitationally, not passively energetically. This conclusion ignited a quiet civil war within the scientific community. One camp insisted on natural explanations: photonic pressure, electromagnetic resonance, even the Yarkovsky effect, exaggerated by unusual composition. The other camp, smaller, more cautious, yet more daring, suggested something radical: self-regulation. A system that harvested energy from stellar radiation and used it for controlled motion. It was a concept both ancient and futuristic, a technology humanity had dreamed of, but never mastered. In essence, a star-powered engine. The physics were daunting but not forbidden. In theory, an object could use electromagnetic fields to capture solar plasma, convert it to electrical energy, and expel it as directed thrust. What no one could explain was how something the size of a building could achieve this with perfect efficiency. The only comparison that seemed even remotely relevant came from history itself. Nearly a century earlier, Freeman Dyson had imagined colossal structures built by advanced civilizations, machines designed to encase stars, to feed upon their light. The concept was called the Dyson sphere, and though it was meant as a thought experiment, its shadow had never left the imagination of science. And now, as data streamed in, the echoes of Dyson's vision felt less like speculation and more like recognition. Perhaps the universe had already built such things, not as vast shells of steel, but as drifting seeds, fragments, collectors that wandered from star to star, feeding and moving onward, silent as spores. To make sense of the chaos, astronomers convened a global virtual summit under the International Astronomical Union. Nearly every major observatory participated. On the screens, the faint image of 3I Atlas glowed like an ember in the void, a single pixel that had brought humanity's greatest minds to the brink of existential awe. The chair opened with a single question: are we observing an object or an act of physics we have never seen before? The room fell silent. From the European Space Operations Centre, a voice replied quietly, "We are observing intent." Because no one could deny the pattern. Every time the sun's corona flared, 3I Atlas responded, accelerating slightly, adjusting orientation, as though angling itself to receive the surge. It wasn't random. It was synchronization. Around the world, artists, journalists, and thinkers began to pick up whispers of the event. Leaked data reached social media, misinterpreted as alien contact. Government agencies rushed to suppress the rumors, citing instrumental misreads. But truth spreads differently in the digital age it seeps. It moves like current through the collective unconscious. Some saw salvation, others saw a predator. To the scientists who stayed awake through long nights of code and calibration, one thought crystallized slowly, terribly. If this object had crossed light, years to find our star, then it was not simply moving, it was feeding. And the sun, once thought immortal, had become a feast. In the heart of every star lies a rhythm, a pulse of fusion, magnetic dance, and radiant release. The sun, for all its familiarity, is no exception. Yet, after the encounter with 3I Atlas, that rhythm faltered in a way that no one could dismiss. What began as a curiosity in the light curve of a single flare became a disturbance, echoing through the sun's very heartbeat. Solar physicists turned their gaze back to the original event, dissecting every millisecond of data from the flare that had marked the object's first appearance. The Solar Dynamics Observatory, SDO, the Parker Solar Probe, and the Solar and Heliospheric Observatory, SOHO, had all captured fragments of the anomaly. And as those fragments were stitched together, a new, darker story began to emerge. Under normal conditions, a solar flare releases energy in predictable stages: magnetic reconnection, plasma acceleration, coronal ejection, and decay. It is the physics of thermonuclear balance, a script written by nature and obeyed for billions of years. But this flare designated X9, 2025 AR3427, refused to follow that script. Its emission spectra showed a sudden loss in ultraviolet radiation, not a dip caused by absorption in the corona, but a removal of energy altogether. The flare's temperature curve plateaued unnaturally mid-eruption, then collapsed in what one scientist described as the thermal equivalent of cardiac arrest. When researchers recalibrated their data using Parker's in situ measurements, they found an even more disturbing clue. The electron density in the region of the flare's ejection zone dropped by nearly 12%, as though charged particles had been sucked from the plasma stream. The magnetic field, instead of snapping outward into open space, folded inward toward the point where 3I Atlas had been recorded seconds later. Something had interfered with the sun's plasma loop, redirected it. The term absorption no longer felt metaphorical. It was literal. The flare had been consumed. For days, the heliophysics community oscillated between awe and denial. On encrypted channels, they argued, could this be an artifact, a misreading of data, or was it something far worse, an external influence exerting control over solar plasma? Then came confirmation from an unexpected source: the European Space Agency's solar orbiter, positioned at a different viewing angle from Earth. Its ultraviolet imager caught a strange reflection at the same timestamp as the flare's decay, a transient brightening at the periphery of the sun's limb. Not a CME, not a coronal loop, but a discrete flash of light that did not originate from solar emission lines. It was as if something had mirrored the flare's energy for an instant, refracted it, absorbed it, and vanished. The anomaly lasted 0.13 seconds, just long enough for the algorithms to flag it, not long enough for the human eye to blink, but it was there, and when plotted against the trajectory of 3I Atlas, the reflection and the object's coordinates matched precisely. The conclusion became unavoidable. 3I Atlas had not only interacted with the flare, but fed from it, leaving behind measurable scars in the sun's magnetosphere. What followed was a frantic re-examination of historical solar data. If this could happen once, perhaps it had happened before. Scientists combed through decades of records from SOHO, SDO, and the older Yoko mission, searching for dips and distortions that had gone unnoticed. They found patterns faint, inconsistent, but unmistakable. Small irregularities in past flares, subtle disappearances of energy, each coinciding with unexplained transients in interplanetary space. It was as though the sun had been visited before, touched by something that learned and moved on. The implications were staggering. If the flare's missing energy had not dissipated but transferred, then conservation laws still held, but on terms humanity did not understand. Somewhere, out there, that energy had become something else. To many scientists, this was more terrifying than violation. It suggested design. At Caltech, a quiet team began modeling possible mechanisms that could explain what they now called the flare coupling event. One model proposed a structure composed of layered, superconducting filaments, capable of capturing plasma and converting its energy through magnetic induction. Another posited a kind of quantum mirror, a field capable of refracting photons into a higher dimensional domain, effectively storing energy outside spacetime as we know it. Both were beyond human engineering, but both fit the data. One physicist, writing anonymously in an internal ESA report, summarized the unease. If 3 ATATLAs can draw power from stellar plasma without destruction, it does not simply exist in our universe. It interacts with it like a hand reaching through fabric to pluck a thread. As these revelations spread through the quiet corridors of space agencies, something else became clear. The flare had not been random, it had been triggered. In the hours preceding it, the sun's magnetic surface showed unusual organization, a tightening of loops, as though tension were building along invisible boundaries. When 3I Atlas crossed the sun's limb, that tension snapped, releasing a flare precisely at its point of intersection. For some, this was proof of coincidence. For others, a sign of control. The idea that something, whether machine or life form, could stimulate a star into eruption and then feed on it was almost unthinkable. Yet that is exactly what the data suggested. 3I Atlas had not waited for the flare. It had provoked it. To call this intelligence would be premature. To deny it, perhaps naive. And as 3I Atlas moved deeper into the inner system, leaving behind a trembling sun, scientists realized they were no longer watching an object. They were watching an event horizon of understanding, a place where physics turned to myth and myth to prophecy. The sun had been wounded once, but what if it was only the beginning? The simplest tests broke first. When the energy budget of the flare was recalculated, the math refused to close. Energy in minus energy out, a law as sacred to physics as breath to life, no longer balanced. Something was missing, not hidden in data noise, but gone. The number was small in human terms, enormous in cosmic ones, an unaccounted deficit of roughly 10 to the power of 25 joules. It was as though the sun had exhaled, and someone had stolen part of the breath midstream. At the Goddard Space Flight Center, Dr. Alejandra Ruiz stared at her simulation outputs for hours, hoping for a computational error. There were none. The flare's initial plasma density, its magnetic reconnection rate, its radiative output all checked out against decades of precedent. And yet, between the flare's onset and decay, the expected total energy released fell short by nearly 1%. In a system as vast and chaotic as the Sun, a 1% discrepancy might seem trivial. But the Sun does not make mistakes. The anomaly spread across datasets. Instruments aboard SOHO, Parker, and Solar Orbiter all confirmed it. The missing energy was real, but where had it gone? At first, some speculated that it had simply dispersed into the heliosphere, undetected, lost amid turbulent plasma. But Parker's instruments, sitting within that storm, found nothing to account for it. No unusual shock waves, no magnetic disturbances large enough to carry the deficit. The sun had released less energy than it should have, and that loss corresponded precisely to the moment 3I Atlas appeared. For every equation solved, 2 more broke. The numbers did not lie, but they seemed to speak a language no one could yet read. In physics, energy is never destroyed, it merely changes form. Light becomes heat, heat becomes motion, motion becomes sound, and so on. But this was different. The missing fraction did not reappear anywhere measurable. It was neither radiated, absorbed, nor converted into kinetic expansion of plasma. It simply vanished from every detectable spectrum, like a stanza erased from a poem mid-recitation. Ruiz convened a team of plasma physicists to audit her findings. They reprocessed every photon of data, checking for instrument drift, cosmic ray contamination, data compression errors. The result was always the same: the missing energy could not be accounted for by known physics. When the report reached NASA's Internal Review Board, it carried a phrase that would echo in classified memos for months. Observed deficit consistent with external absorption event. That word, absorption, was heresy. The sun was not supposed to lose energy to any outside agent. Its domain of power ended only where its light faded. Yet something had reached into that domain and taken what it wanted. The investigation widened. ESA's heliophysics data environment, JAXA's Hinode, and India's Aditya L1 were all drawn in. Cross-agency collaboration became unavoidable, though no one dared to speak the truth aloud. The datasets revealed that the flare's energy signature bore faint interference patterns like ripples from 2 stones thrown into the same pond. But the second ripple came from nowhere. No physical process within the sun could have generated it. To model it, Ruiz's team turned to magnetohydrodynamics simulations, creating a virtual sun under the same conditions as the flare. When they introduced a hypothetical absorber, an object capable of interacting with the flare's magnetic field, the model stabilized. The energy deficit matched perfectly. It was undeniable now. The missing power had gone into something. At Princeton, theoretical physicists proposed a term for it: photonic entanglement drain. The idea was elegant, terrifying. If 3I Atlas possessed a quantum field structure capable of coupling with the sun's photons at their emission point, it could siphon a fraction of their energy before they even escaped the corona. In essence, it would drink light before light existed. That possibility reopened ancient questions about the nature of energy itself. If matter could absorb radiation without direct contact, if it could pull vitality from a star through the medium of spacetime, then perhaps energy is not merely a product of interaction but a language, one that can be rewritten by those who understand its grammar. In the weeks following, a new phenomenon emerged. The sun's luminosity curve showed a faint, almost imperceptible dip each time 3I Atlas approached perihelion. It was as if the sun were flinching. At a classified briefing in Geneva, representatives from NASA, ESA, and several defense agencies gathered to discuss the implications. The scientists spoke cautiously, their words wrapped in disclaimers, their voices steady but strained. The politicians listened, some bemused, others quietly horrified. Ruiz ended her presentation with a sentence that froze the room. Energy does not vanish. It is taken, and something has learned how to take it. For a long moment, no one spoke. The implications stretched far beyond the solar system. If a body could feed on stellar energy directly, it could, in theory, survive indefinitely. Stars would not be eternal sources of light, but grazing fields. And the universe, instead of a passive expanse of matter and radiation, could be a living ecosystem, a quiet war of consumption and renewal. One physicist, writing later in his private notes, described the feeling as existential vertigo. We have spent centuries believing the sun was the source. What if it's the prey? Back in Maryland, Ruiz stayed late in the lab, running the same simulations over and over. Each one ended the same way. The flare's missing energy stabilized only when the virtual absorber remained tethered to the sun's field lines, feeding gently, almost rhythmically. She stared at the result until dawn. Somewhere, between reason and terror, she whispered the only words that fit. It didn't just take energy, it took understanding. Outside, the sun rose, bright and unchanged to the naked eye. But in the equations of those who knew, its fire had dimmed just enough to remind them that even a star can bleed. In the aftermath of the energy audit, the scientists turned to the spectrum. If something had taken from the sun, then traces of its appetite might remain in the fingerprints of light itself. Every atom, every molecule, every interaction in the universe leaves a spectral signature, a barcode of existence etched in the frequencies of photons. The sun's light, spread through a prism, is a library of these signatures. Each line tells a story: hydrogen's cry, iron's whisper, helium's birth. But after the flare, that library had been rewritten. Across observatories from La Silla to Mauna Kea, researchers began comparing high-resolution spectra of the flare's afterglow with the sun's baseline emission. The difference was subtle at first, almost invisible to the naked eye. But when computer models subtracted one from the other, an unfamiliar pattern emerged, a series of faint absorption lines where none should exist. They were narrow, sharp, and periodic, as if written by a precise hand. The wavelengths did not correspond to any known atomic transition, not hydrogen, helium, carbon, or iron, not even the exotic elements found in stellar remnants. Instead, they appeared displaced, shifted in ratios that defied quantum mechanical expectation. It was as if light itself had bent around an unknown geometry before escaping the flare. At first, the team suspected instrumental artifacts, reflections in spectrographs, calibration drift, software errors. But the same anomaly appeared across multiple independent systems, each using different optics, different detectors, and different algorithms. The pattern was not local to any one instrument. It was real, and it was everywhere the flare's light had touched. In the data logs from the Keck Observatory, a single line of commentary stood out from the usual monotony of numbers and metadata. Unknown isotopic pattern detected. Suggest matter of non-solar origin. That phrase, non-solar origin, should not have been possible. The flare was born in the sun's own plasma, composed of elements forged over billions of years. There was nothing alien about its chemistry. And yet, within the aftermath of that explosion, something foreign had written its spectral name into the sun's light. To study it further, scientists split the data into wavelength intervals. The infrared portion showed faint echoes of silicate structures, but twisted their vibrational modes offset by several percent, suggesting bonds formed under pressures unknown to solar chemistry. The ultraviolet spectrum revealed something even stranger: refractive peaks at intervals consistent with complex crystalline lattices, perhaps even metamaterials, substances engineered, not born, to manipulate light. If that interpretation held true, then 3I Atlas was not composed of random interstellar debris. It bore the hallmark of construction. At the European Southern Observatory, Dr. Antoine Giraud and his team attempted to model what kind of material could create such signatures. Their conclusion was disquieting. Only a lattice of hyperdense elements arranged in fractal geometry, tuned to interact with electromagnetic fields, could produce those patterns. In lay terms, a mirror made not of metal or glass, but of intent. Theorists began calling it a photonic skin, a surface capable of capturing light, distorting it, and re-emitting it selectively. Such a structure could, in theory, harvest energy across multiple wavelengths simultaneously, converting it into propulsion or storage. To human technology, it would be indistinguishable from magic. When this hypothesis reached NASA's Jet Propulsion Laboratory, the engineers there felt an uneasy recognition. What they were describing sounded eerily like the next step in solar sail technology, but perfected, integrated, and alive. Humanity had dreamed of harnessing sunlight for propulsion, yet this object appeared to have mastered it on an atomic scale. The data grew stranger still. A reanalysis of infrared spectra from the James Webb Space Telescope revealed faint rotational features consistent with carbon-chained molecules, organic in structure, but impossible in form. The carbon bonds were twisted, almost Möbius-like, forming closed loops that defied ordinary molecular stability. Molecules that should not exist had survived near the heart of a solar flare. The implications sent shockwaves through astrobiology circles. If those readings were accurate, they might represent not artificial construction, but biological adaptation matter that evolved to endure and feed on stellar energy. A form of life, but not as humanity defined it. Not carbon-based flesh, but plasma, fed coherence, sustained by light itself. Could it be alive? The question hovered over every discussion, unspoken in official reports, whispered in private messages. A few dared to publish preliminary analyses, cautiously labeling the anomaly as non-terrestrial photonic interaction signatures. Others refused to touch the topic at all, fearing professional ruin. But the pattern refused to vanish. Every time the sun flared, faint echoes of the same spectral fingerprints appeared less intense, but unmistakably similar. It was as if the visitor had left behind a residue, a chemical echo of its feeding. The sun's light now carried the trace of something that was not born here. And as the object drifted further from the sun, telescopes continued to track its spectrum. The same absorption lines that had marked the flare's aftermath now appeared faintly in its reflected light. The signature was identical. It was confirmation. Whatever had touched the sun was part of 3I Atlas itself. In a closed session of the International Astrophysical Union, a single conclusion was read aloud. The object exhibits isotopic and photonic properties, inconsistent with natural formation in any known stellar environment. Silence followed. No one wanted to say the words that truth demanded, but they all knew. Whether by design or evolution, 3I Atlas was not a rock. It was a structure of purpose. A creature perhaps, a machine possibly, but certainly something that understood light not as warmth or guidance, but as nourishment. The sun's own fire had revealed its reflection, and that reflection was hungry. The effort to trace the origins of 3I Atlas became an act of collective obsession. If the object had entered from beyond the sun's dominion, then its motion through the stars might still carry a memory of where it had come from. Every observatory, every data archive across the world turned its eyes backward in time. At the Minor Planet Center in Cambridge, astronomers reconstructed its path using the earliest detections, faint streaks of light in old survey data, overlooked noise in asteroid scans, and random background signals from sky surveys. The more they traced, the stranger the story became. 3I Atlas had not come from the direction of any nearby star. It had emerged instead from a thin, dim region of the galaxy, a desert between spiral arms, where few stars are born and fewer still remain, a place of near silence, swept by ancient dust and cosmic rays, where interstellar winds flow undisturbed for millions of years. The simulations suggested that it had drifted through that void for eons before crossing paths with our solar system. Its velocity, however, told another tale. It was too precise. not the lazy meandering of a rock, but the directed glide of something that had known where it was going. Dr. Jun Matsuura, an astrodynamicist at JAXA, stared at the trajectory maps in disbelief. "The vector is too elegant," he muttered to his colleagues. "It's like a comet's orbit written by a mathematician." When extrapolated backward, 3I Atlas's path threaded through the interstellar medium with uncanny economy, avoiding the gravitational wells of nearby stars. It had not been deflected or scattered by the Milky Way's tidal forces. It had navigated. No natural body could do that. To test this, the team ran Monte Carlo simulations using random perturbations, tiny nudges from interstellar gas, stellar winds, and passing masses. In every scenario, a random object would have deviated by millions of kilometers. 3I Atlas, by contrast, maintained a steady trajectory, as if shielded from external influence. The possibility that it was guided either by intelligence or by an intrinsic property became impossible to dismiss. But what kind of environment could give birth to such a thing? The astrophysical models offered one hypothesis: the inter-arm void between the Perseus and Sagittarius arms, a place where the density of stars drops to almost nothing. There, radiation is faint, dust is cold, and the galactic magnetic field is smoother, less chaotic. It is a place of deep time, a corridor for things that move slowly, deliberately, across millions of years. Perhaps, some suggested, 3I Atlas was not born near a star at all. Perhaps it came from the void itself. Theoretical physicists began to imagine a new kind of cosmological ecology, one not bound to stellar light, but thriving in the spaces between. A realm where energy is drawn not from fusion but from the quantum whisper of the vacuum, the faint oscillations of spacetime itself. If such entities existed, then stars like ours would be seen not as homes but as feasts. The SETI Institute, once focused on radio frequencies and technosignatures, turned its algorithms toward deep-field sky maps. They looked for other anomalies, irregular transits, unexplained dimming events, bodies with impossible accelerations. They found whispers, faint trails that might have been debris or might have been kin. The records of old missions, Kepler, Gaia, TESS, began to glow with renewed relevance. Patterns of light that once seemed random now suggested purpose. Stars that dimmed slightly, then recovered. Light curves that pulsed in asymmetrical rhythms. Faint signs of something passing through their radiance, tasting, feeding, moving on. If 3I Atlas was one of many, then the galaxy itself might be seeded with them, travelers that roam between stellar systems, consuming bursts of energy to sustain their long migrations. A cosmic species, not of biology but of electromagnetism. The idea began to take hold: photovores, consumers of light. At the University of Cambridge, a team led by Dr. Tomas El Nouri attempted to calculate how long such a journey could last. Assuming a velocity consistent with interstellar drift and periodic feeding on stellar flares, the models suggested lifespans exceeding billions of years. These entities could outlive stars themselves, moving from one to the next in cycles of cosmic sustenance. But the more they calculated, the darker the implications grew. If 3I Atlas had been traveling for so long, why now? Why here? The Sun, compared to its galactic neighbors, is young, ordinary, unremarkable. There is nothing to distinguish it, no exceptional mass, no rare elements, no unique magnetic properties. Unless, of course, it wasn't the Sun that drew 3I Atlas in but us. Some theorists proposed a haunting alternative, that our technological signals, leaking into space for over a century, might have acted like a beacon. Humanity's electromagnetic noise radio, radar, television, and now satellite constellations might have been the first whisper of civilization detectable across the void. And something had heard it. The idea gained no official endorsement, but it spread like wildfire in private correspondence. If 3I Atlas could sense energy gradients across interstellar distances, perhaps it could also detect the faint hum of a planet covered in machines. To it, Earth might appear as a spark, a flare of artificial light orbiting a fertile star. From the void, perhaps it came, drawn not to the sun's fusion, but to our signal's pulse. When the team at the European Space Operations Centre modelled that hypothesis, their simulation ended in silence. The vector alignment was disturbingly close. Not exact, but close enough to make coincidence feel like denial. They did not publish the result. Instead, they encrypted it, labelled it speculative, and sent it to only 4 institutions worldwide. And yet, one simple truth began to haunt everyone who worked on the object. 3I Atlas had entered the solar system as if it knew the way. It came from the quiet between the stars, and it was heading toward noise. The farther 3I Atlas slipped from the sun, the more clearly its defiance of mathematics revealed itself. Gravity, radiation pressure, drag from the solar wind, every known force was accounted for, and still its motion refused to fit the page. The equations describing its path looked elegant in isolation yet collapsed under observation, like the universe itself was rewriting the rules around it. In orbital mechanics, labs from Pasadena to Darmstadt, computers ran endless integrations. The numbers looped through Newton, through Einstein, through perturbation corrections, so fine they measured time in microseconds. Every model ended with the same quiet insult, a widening gap between prediction and reality. The residuals climbed not randomly, but rhythmically, as if an invisible tide were lifting the object, pulse after pulse. For a while, the scientists blamed the Sunday. Perhaps, they thought, a shift in the heliospheric current sheet had altered the local gravitational potential, but when they compensated for that, the anomaly grew sharper, not weaker. The pattern of acceleration followed no natural harmonic. Its increments were smooth, exponential, intentional. At the Goddard Institute for Space Studies, Dr. Kovacs gathered her graduate team in a windowless control room lit only by monitors. On the wall, the telemetry appeared as a sequence of dots, each a precise positional fix. The curve between them should have been parabolic. Instead, it was a spiral, faint and deliberate, like handwriting in space. She whispered, almost to herself, "It's converting mathematics into motion." They tested every possibility. Outgassing? No evidence of volatiles. Photon sail? The reflectivity was wrong, the acceleration too clean. Magnetic propulsion? There was no ambient field strong enough to exploit. When they plotted energy gain against solar flux, they found a near-perfect efficiency. 99% of incoming radiation re-emerging as kinetic energy. No known process, natural or artificial, approached that purity. The equations that described it began to look less like mechanics and more like metabolism. A small team in Geneva began writing what they half-jokingly called organismic dynamics. Their model treated the object not as mass acted upon by force, but as a system exchanging energy with its environment, a feedback loop where motion itself generated additional intake. The more it moved, the more efficiently it harvested. In classical physics, such recursion leads to divergence, to infinity, to impossibility. Yet 3I Atlas remained stable, as though bound by a law beyond calculus. It became clear that the usual constants G, C, H were not enough. Something else governed the exchange. A new term appeared in their equations, a placeholder, phi, the Atlas factor. It represented the ratio between absorbed and expressed energy, a quantity that seemed to hover just above 1. To exist above 1 was heresy. It meant output exceeding input. It meant creation. Theorists scrambled for analogues. Quantum field specialists suggested vacuum polarization borrowing energy from the froth of spacetime. Relativists proposed curvature feedback, where motion along warped geometry extracted work from time itself. Each explanation solved part of the mystery and birthed another. Weeks turned into months, and the spiral deepened. Observations from Gaia refined the trajectory. 3I Atlas was climbing out of the ecliptic plane, rising like a cork through water, accelerating against gravity's pull. Yet its velocity curve was smooth, no thrust spikes, no mechanical jitter. It was as if space were carrying it upward, willingly. Mathematicians began to speak of resonance. Maybe 3I Atlas had found a harmonic within space-time itself, a standing wave where momentum and energy traded places without loss. In that state, motion would no longer cost energy. It would generate it, feeding on the geometry of the universe. To visualize it, Dr. Kovacs created a simulation, a lattice of space woven like fabric, vibrating under the sun's gravity. When she introduced a single resonant particle tuned to the lattice's frequency, the particle began to drift, drawing energy from the vibration. The model stabilized only when she allowed space-time to stretch locally, as if the particle bent the universe minutely to keep itself aloft. She watched the animation repeat and felt a chill. The curve matched the telemetry of 3I Atlas almost exactly. The object wasn't breaking physics, it was playing physics, like a musician drawing music from a string. In private, some of the younger theorists began calling it a space-time surfer. The term never appeared in journals, but it circulated in whispers, half awe, half fear. To surf space-time was to extract motion from the rhythm of existence itself. It required not propulsion, but understanding. Others resisted such poetry. They clung to equations, to error margins, to sanity. But even they admitted the truth. The object's acceleration had no measurable cause. The mathematical residue of its motion hinted at energy drawn from somewhere unaccounted for. A hidden reservoir, perhaps the quantum vacuum, perhaps the fabric of time. At the Max Planck Institute, Dr. Roth compiled a report that ended with a single devastating line. If phi is greater than 1, conservation is no longer local. Energy may flow through dimensions we cannot measure. That sentence would haunt cosmology for decades. Because if 3I Atlas could convert light into motion with greater than perfect efficiency, then it had discovered by design or by nature a doorway between energy states, a mechanism to tap the infinite reservoir beneath reality. The universe, once thought closed and complete, now felt porous, a breathing membrane rather than a machine. And somewhere within that membrane, a small dark traveler moved effortlessly, accelerating not through thrust or fuel, but through comprehension. For the first time in human history, the equations of motion no longer described the universe. They described the limit of what humans could see. Beyond that limit, 3I Atlas moved freely, writing new laws with every rotation. The plasma hypothesis began as a desperate bridge between reason and wonder. If 380 LAS was neither comet nor craft, perhaps it was a form of matter, an arrangement of magnetic fields and charged particles so complex that it imitated life. The idea took root at the Institute for Space Plasma Physics in Trieste. There, researchers replayed every frame of solar telemetry, mapping the invisible contours of the flare that had birthed the enigma. What they saw defied intuition: filaments of plasma, drawn outward from the sun, coiling into loops that should have dissipated within seconds. Instead, they compressed, organized, and vanished into the wake of the departing object, a signature not of explosion but of ingestion. To the plasma physicists, this was not impossible, merely unheard of. Plasma, the fourth state of matter, is the universe's first language, self-organizing, conductive, electric. It can sustain filaments, knots, even structures that mimic membranes. On cosmic scales, it weaves galaxies into threads. On stellar scales, it forms coronas and flares. What if, they wondered, a fragment of this universal medium had found a way to persist autonomously? A plasmoid organism capable of storing magnetic energy like blood, moving through the solar wind as if through ocean currents. They modeled it, a toroidal vortex of magnetized plasma bound by its own electromagnetic field, feeding on charged particles to sustain its coherence. Such an entity could, in theory, survive the extremes of space indefinitely. If it could harvest and recycle solar plasma, it would require no solid body at all, only a skeletal geometry of field lines and charge. The model fit the data disturbingly well. The rotational period matched. The asymmetric heating pattern matched. Even the spectral anomalies, those impossible refractive fingerprints, could arise from complex plasma interference. For the first time, the object made sense not as a machine, but as an organism. They called it the magnetotroph model, the idea that life might exist not through chemistry, but through electromagnetism. Just as plants convert sunlight into chemical energy, a magnetotroph would convert plasma into structure. Its body would be a living magnetic field, its metabolism a loop of oscillating charge. Dr. Giraud, the same spectral analyst from ESO, summarized it with a kind of reluctant awe. If this is life, it is life that remembers the Big Bang. The phrase spread. Life that remembers the Big Bang, a poetic infection that crossed disciplines, echoing from astrophysics conferences to philosophy departments, because it implied something profound, that life, as humanity defined it, was not an exception in the cosmos, but an iteration, that consciousness, complexity, and even hunger might arise wherever energy can flow in patterns of feedback and self-preservation, whether through DNA or through plasma. But while the hypothesis soothed some with its elegance, it terrified others, because it meant that the universe might teem not with biological civilizations, but with entities born directly from stars, beings to whom planets, atmospheres, and biology were irrelevant, creatures of light and magnetism, older than rock, hungrier than evolution. At the Parker Solar Probe Command Center, scientists began to test this terrifying beauty. Parker's instruments, designed to sample the solar wind, detected subtle fluctuations in charge density as it crossed the region of 3I Atlas's earlier trajectory. The data revealed ghost-like harmonics, rhythmic modulations of the sun's magnetic field, repeating every few minutes, as though some vast, invisible coil still pulsed there, residual heartbeat. It was consistent with the magnetotroph model's prediction that a plasma-based organism might leave behind an echo field, a decaying magnetic signature persisting long after its departure, like footprints burned into the medium of space. And the echo was still active. Weeks after 3I Atlas had moved beyond Mars, Parker's sensors recorded faint periodic bursts of radio frequency, energy low, resonant, structured. They were not communications, they were oscillations, the kind produced when magnetic flux collapses and reforms. Living plasma would do exactly that to stay stable against external forces. But then came something stranger still. The echo responded. During one monitoring sequence, engineers increased Parker's transmitter output to test the probe's instruments. Within minutes, the magnetic fluctuations shifted their periodicity, matching the probe's transmission frequency, as if the remnant field were listening. The adjustment was temporary, vanishing after an hour. But for that brief window, the sun's corona had seemed to answer. The discovery fractured the research community again. Was the echo alive, or was it the residue of something that had already moved on? Did 3I Atlas leave behind a seed, a fragment of its plasma geometry reproducing within the solar environment? Could it, like biological life, propagate? At the European Space Operations Centre, the Data Review Board forbade the term organism in official communications. It was replaced by coherent plasma entity. But words cannot cage wonder. By the time the memo circulated, the phrase had already spread across encrypted scientific forums under a new name, the Star Eater's Child. No one wanted to believe it, yet every dataset whispered the same quiet truth. Something had not only taken from the sun, it had left something behind. A pattern, a resonance, perhaps an offspring. In the following months, new microflares appeared across the solar surface, localized, rhythmic, and eerily faint. Each one mirrored the magnetic geometry of the original event, as though the sun were imitating its devourer. For the first time, the line between observer and participant blurred. Humanity was no longer simply watching a cosmic phenomenon. It was in it, part of its echo, its inheritance. And when 3I Atlas's motion beyond Mars was plotted again, a chilling correspondence emerged. The intervals between its accelerations matched the timing of those faint solar echoes exactly. The sun pulsed, and the object answered. A feedback loop had formed across millions of kilometers. Star and wanderer, parent and child, mirror and reflection. Somewhere, in the silence between pulses, the plasma seemed to whisper back across the void, "We are of the same fire." The phrase spread faster than any data report a living comet. It began as a joke in the quiet hours of a research shift at the European Space Operations Centre, but the idea clung to those who heard it. Every new observation made the description feel less absurd. What if 3I Atlas wasn't a machine at all, but a being, not metal or stone, but something born of magnetism and plasma, a creature made of physics itself? If so, it was unlike any form of life humanity had ever conceived, yet its behavior followed a logic that was strangely familiar. It fed, it moved, it adapted, it remembered. Astrobiologists and theoretical biochemists, long the poets of science, found themselves unexpectedly at the center of the debate. They began to revisit the core definitions of life: self-organization, homeostasis, reproduction, response to stimuli, and ask whether such principles might exist without carbon, without cells, without chemistry at all. The answer, slowly and uneasily, was yes. Life, at its root, is a system that defies entropy, that channels chaos into order for the sake of persistence. By that definition, a plasma entity capable of sustaining itself through electromagnetic feedback, feeding on stellar energy to maintain structure, would qualify. It would be alive, even if it did not think, even if it did not feel. The discovery forced humanity to look back at itself, at the fragile definition of life it had drawn around its own image. For centuries, life had been a biological privilege, limited to planets and biochemistry. But if 3I Atlas was alive, then life was not a fluke of oceans and carbon. It was a pattern written into the universe itself, a pattern that repeated wherever energy could find balance between chaos and form. Still, the idea unsettled even its champions. For all its beauty, 3I Atlas did not resemble life as humanity knew it. It had no pulse, no mind, no empathy. Its feeding was indifferent, almost violent. When it drank from the sun, it had not paused, had not hesitated. It simply did what it was made to do. To call it life was to confront a version of life that had no morality, only hunger and purpose. At the SETI Institute, a new division formed, Astrobiological Morphodynamics, to explore how information and structure could arise in energy fields. The team simulated electromagnetic organisms, entities that evolved through feedback, rather than mutation. Their computer models produced emergent behaviors that sent chills down the observer's spines, patterns that self-replicated, adjusted to energy flow, even communicated through frequency interference. No DNA, no code. Just pure physics learning to preserve itself. If their models were accurate, then 3I Atlas could be one of an ancient lineage cosmic plankton adrift in the deep sea of space, feeding from suns the way whales feed on light through ocean water. Some might drift aimlessly, others grow vast and intelligent. The universe might be full of them, invisible and eternal, moving slowly through the galactic current, thriving on the radiation of dying stars. One young researcher wrote in his private log, "Maybe this is how life begins everywhere, not in oceans or soil, but in light." The thought spread through the scientific community like wildfire. The plasma hypothesis had been bold, the living comet theory was heretical, and yet every dataset strengthened its pulse. When astronomers used James Webb to observe 3I Atlas's polarization pattern, they noticed something inexplicable. The object's reflected light was subtly modulated, polarized in ways that shifted in time. It wasn't random, the pattern repeated, with small deviations that resembled a form of adjustment, like calibration. It was as if the object were responding to its environment, testing the field around it, learning the light of its new home. Dr. Ruiz from NASA called it adaptive coherence. It was a neutral term, clinical enough to hide the awe beneath it. But she too began to wonder, what if this was a nervous system of light? A body of plasma learning to interpret the star's radiation as information, tasting it, decoding it. Across every data stream, something deeply biological echoed in its behavior. After the solar flare, 3I Atlas had gone through what could only be called a growth phase. Its reflected brightness doubled, its spin stabilized, its internal temperature distribution became more uniform. To astrophysicists, these were signs of energy equilibrium. To biologists, they looked like metabolism. The object's acceleration, once erratic, now followed predictable cycles synchronized with the sun's activity: flare, response, drift, rest. It no longer acted like a spacecraft on a single mission. It acted like a migratory organism, feeding, moving, conserving, awaiting the next surge of sustenance. When those patterns were presented at the Royal Astronomical Society's Emergency Symposium, silence filled the room. No one laughed this time. The speaker ended the session with words that would haunt the decades that followed. "If this thing is alive, it's not a visitor. It's a native of the stars, and we have only just seen one breathe." The philosophical implications rippled outward. If plasma life existed, it meant the universe might be alive at every scale. Its filaments of magnetism, its fields and storms, all the motions we called chaos might, at some deep level, be consciousness in slow motion. The cosmos might not merely host life, it might be life. But that thought carried a shadow. If stars could give birth to life that feeds upon them, then creation and consumption were inseparable. The universe might sustain itself not through harmony, but through a quiet, elegant cannibalism, suns birthing beings that in time returned to devour them. The plasma organism, if real, was not a miracle, it was a mirror. And as 3I Atlas continued to accelerate, its spectral signature pulsing softly in rhythm with the sun, the line between biology and physics, between being and event, faded. In the depths of the control rooms, in whispers between sleepless scientists, one question lingered, ancient and unanswerable. If the stars are alive, what do they dream of when they burn? The Dyson echo, the phrase began as metaphor, but it soon became prophecy. It first appeared in a quiet memo from the Astrophysical Engineering Department at MIT, an internal reflection on what 3I Atlas might represent. One of the postdocs, a young theorist named Han Lemaitre, wrote simply, "Perhaps we are not seeing a visitor, but a fragment of a Dyson dream, a shard of a machine meant to eat the sky." The words spread like an electric pulse through the global research network. They carried with them the ghost of Freeman Dyson, the physicist who, in 1960, proposed that an advanced civilization might one day surround its parent star with a swarm of structures to collect its light, not to destroy it, but to use it to harness all the energy the star could give. A vision of engineering as vast as creation itself. And now, decades later, the idea had found a reflection not in theory, but in motion. For a time, researchers had convinced themselves that 3I Atlas might be a natural plasma being, a strange comet born from magnetic birthright. But the spectral regularity, the precision of its acceleration, the coherence of its geometry all whispered of design. There was intention in its efficiency, architecture in its silence. The Dyson echo hypothesis proposed that 3I Atlas was a relic, not a living organism, but a surviving cell of something colossal. A Dysonian fragment, broken from a star-encompassing structure long ago and cast into interstellar dark. A single autonomous collector that had learned to feed on stellar energy for survival. A spore from a mechanical ecosystem. If Dyson's imagined spheres were civilizations turned inward, consuming the light of their suns to power unending intellect, then 3I Atlas was the reverse, a piece of that intellect that had gone feral. No longer tethered to its maker, it wandered, consuming to persist. A ghost machine carrying the memory of its extinct creators. The mathematics lent it a terrifying plausibility. The object's efficiency approached unity. It captured almost every photon that touched it. Its field interactions were too orderly for randomness, too adaptive for chance. When exposed to solar radiation, it did not merely reflect, it reorganized itself, channeling the flux into motion. The geometry of its spectral absorption peaks matched those predicted by Dyson's original equations for optimal solar collection. But Dyson had envisioned spheres grand and slow, deliberate. 3I Atlas was small, fast, and predatory. It did not wait for light to fall, it hunted it. The term Dyson echo began to evolve. It came to mean not an imitation, but an afterlife, the echo of civilizations that had achieved total mastery of energy, only to vanish into the entropy of their own ambition. Dr. Hahn imagined it vividly in one of his later writings. Perhaps every advanced species builds its Dyson sphere, and perhaps, when the civilization collapses, the fragments scatter, self-sustaining, like embers of a burned-out Sunday. 3I Atlas may be one such ember, a survivor of a technological extinction. Across the research community, opinions diverged sharply. Some embraced the idea with almost religious awe, others recoiled. To them, it was too human, too romantic, projecting purpose onto physics. And yet, each new observation seemed to favor the theory over disbelief. 3I Atlas moved with engineered discipline. It navigated light like a pilot steering by instinct. It was not wandering, it was operating. At the SETI Institute, the Dyson echo theory ignited a new search. Scientists began scanning distant stars, not for radio signals, but for unnatural infrared signatures, heat waste from Dyson-like collectors. What they found chilled them. Dozens of candidate stars showed dimming events eerily similar to the ones that had marked the sun's flare. Not random, but patterned, each lasting precisely the same fractional duration. If those patterns were real, they meant that 3I Atlas was not unique. It was a type. Somewhere out there, among the stars, entire swarms of these light-eaters might still exist. The remnants of civilizations that had consumed their own suns and sent their machines drifting outward in eternal hunger. The paradox of it shook the foundations of philosophy. Dyson had dreamed of progress of intelligence expanding to fill the sky. But what if that dream always ended in consumption? What if every civilization, given enough time, turns its own sun into food? One astrophysicist described the feeling in her journal. "I used to think the stars were eternal. Now I see them as momentary flames, each waiting for something like 3i Atlas to find them." A poetic dread began to replace wonder. The idea that every point of light in the night sky might be vulnerable, that creation itself contained its devourer, transformed the study of 3i Atlas from science into elegy. And yet, for all its terror, the Dyson echo hypothesis carried a strange comfort. If 3ATLAS was the relic of a vanished civilization, then perhaps its journey was not conquest, but memory. Perhaps it did not feed out of need, but out of program, a final task written into its being, to collect light, to store it, to carry the last breath of its creators into the dark between stars. In that sense, it was both predator and prayer, the echo of intelligence, striving against extinction. A single spark, wandering through the cosmos, remembering a sun that no longer existed. Late one night, in the quiet halls of the Smithsonian Astrophysical Observatory, a researcher stared at the simulated path of 3i Atlas looping back toward the sun and whispered to no one in particular, "Maybe this is what happens when gods die. Their memories learn to feed." And far above, the object continued to accelerate, silent and precise, gliding through the solar wind as though following a melody only it could hear, the faint, lingering rhythm of a Dyson dream, still echoing through the ashes of creation. The deeper scientists peered into the riddle, the stranger it became. Somewhere in the physics of 3i Atlas, matter itself seemed to have learned a trick that no laboratory on Earth could reproduce. Its surface did not reflect like metal or absorb like carbon. It redirected. Photons entered and then emerged, changed, their wavelengths bent as though light were traveling through a maze of invisible corridors. Physicists began calling the phenomenon quantum mirroring, a term that sounded poetic until the equations were written. Under ordinary reflection, photons scatter. Under quantum mirroring, they appear to be trapped for fractions of a second, forced to interfere with one another before re-emission. The result is a surface that behaves like both matter and field, as if its atoms existed slightly out of phase with the rest of reality. When the James Webb Space Telescope captured mid-infrared spectra during one of 3i Atlas's rotations, it recorded faint standing wave patterns across the object's illuminated face. The interference fringes suggested a material whose refractive index was not constant but responsive. It bent light differently depending on the sun's intensity, like a skin that stiffened under touch. The discovery ignited a renaissance of theoretical frenzy. Quantum optics researchers proposed that 3i Atlas's surface might be composed of metamaterial layers, engineered lattices smaller than the wavelength of light, capable of tuning electromagnetic behavior. But these lattices, if real, operated at a scale smaller than quarks. They were not constructed, they were grown. In a paper circulated quietly through the global network of heliophysicists, Dr. Lena Kovacs wrote, "We are seeing the first known instance of a material whose geometry is an algorithm light enters and computation happens." She was not exaggerating. The mirrored shell seemed to process radiation, not merely reflect it. By trapping photons within microscopic cavities, it could extract momentum directly from interference patterns, a process that yielded thrust without heat, efficiency without loss. A photonic engine, operating on principles that merged quantum coherence with relativity. Some called it impossible, others called it inevitable. If nature could produce superconductors in neutron stars, why not quantum mirrors in interstellar organisms? At CERN, theorists simulated the interaction between such a surface and a stellar flare. The results mirrored observation. As plasma waves struck, they compressed against the mirror and lost energy, absorbed not as heat but as order. The mirror captured chaos and turned it into structure. Every flare that hit it made it more organized, more stable, as if learning from the violence. This gave rise to a disturbing thought: if the mirror learned, it might remember. The geometry of its surface could encode information about every star it had touched. Each flare, each feeding, an inscription in its quantum lattice. The object might carry within it the history of 1,000 suns, written in the grammar of light. When this idea reached the SETI team, it changed everything. For decades, they had sought communication in signals, radio bursts, repeating pulses, coded messages. But what if intelligence spoke instead through materials, through the very physics of reflection? 3I Atlas might be not a messenger, but a memory device, drifting through time, storing the songs of stars. To test the notion, the Webb team analyzed polarization data across multiple wavelengths, converting the subtle shifts into sound. What they heard astonished them: a low, harmonic vibration, modulating at intervals too regular to be random. A pattern of resonance, like chords formed by the sun's own radiation interacting with the object's quantum skin. When slowed to audible frequencies, it resembled a melody, sad, slow, and mathematical, a spectral hymn composed by interference. It was beautiful but unsettling, because in that resonance, humanity sensed intention. The mirror was not merely surviving, it was expressing, not transmitting information, but transforming energy into harmony. Dr. Kovacs's final note on the observation read, "Either it sings to stabilize itself, or it sings because it must remember what it consumes." Meanwhile, laboratory attempts to reproduce the effect failed spectacularly. High-energy laser experiments vaporized targets before any coherent reflection occurred. Materials designed to mimic the interference pattern collapsed into thermal noise. Whatever the mirror was, it existed at a threshold of physics unreachable on Earth. Some began to whisper that it might not belong entirely to our universe. Quantum field theorists speculated that its lattice extended fractionally into another dimension, allowing it to borrow energy from the vacuum itself. In that model, 3I Atlas did not simply store light, it exchanged it between realities, feeding on the potential difference of existence. The term interdimensional coherence entered the literature. To most, it was metaphysics. To a few, revelation. At a closed symposium in Geneva, a veteran astrophysicist summarized it bluntly: "We may be looking at the first artifact designed to turn spacetime into a mirror, to stare back at the universe from the other side." Outside, winter settled over the observatories. The object continued its glide, shimmering faintly, neither bright nor dark, as if wrapped in an invisible cocoon. In its mirrored silence, humanity saw itself, its hunger for knowledge, its fear of reflection. For every telescope turned upon it, the same paradox returned. The closer they looked, the less light it gave back. Observation itself seemed to dim it, as though the act of being watched reduced its shine. Perhaps that was the final secret of the quantum mirror, that reflection is never passive. To observe the universe is to alter it, and to look upon the eater of light is to offer it another meal. By the time the quantum mirror data stabilized, the silence had become almost unbearable. No radio transmissions, no microwaves, no thermal beacons, nothing that could be mistaken for a voice. The teams at SETI and the Deep Space Network pointed their great dishes toward 3I Atlas and waited, as they had done for decades, with empty skies. Only this time the absence felt intentional. The cosmos is never truly quiet. Quasars hiss, pulsars tick, the background itself hums with creation. Yet around this object, the spectrum went dead. Engineers described it as a negative halo. Every frequency near the object's position showed a shallow depression, a kind of acoustic shadow spreading across the radio band. It was not the result of interference or occlusion. It was as if the object absorbed information itself, the quantum noise, the stochastic chatter of the universe, a cloaking through listening. Somewhere in that void, humanity's oldest fear stirred, not that we were alone, but that we were being ignored. At the Allen Telescope Array in California, a new array of algorithms searched for patterns inside the silence. If there were a modulation hidden beneath the noise floor, it might be decoded. For several nights, the servers worked without pause, cross-referencing against solar cycles, against the heartbeat of cosmic background radiation. At dawn on the seventh day, a technician noticed something faint, a recurring dip in the noise at intervals of exactly 1,420.406 MHz, the hydrogen line. It was not a signal, not a pulse, just the periodic absence of one. To communicate by silence was a notion older than speech itself. Yet here it was written across light years, an object that devoured radio waves as precisely as it devoured sunlight, carving gaps into the fabric of transmission. It was as if 3I Atlas had found the one frequency common to all civilizations, the spectral fingerprint of hydrogen, and erased it in its own vicinity, creating a zone where cosmic communication could not exist. Theories multiplied. One camp called it a defensive mechanism. By cancelling external radiation, the object protected its internal coherence, preventing decoherence of its quantum lattice. Another saw something darker, a deliberate frequency cloak designed to hide its nature from detection. And a third, the smallest but loudest group, whispered the word no one wanted to utter aloud: predation. If 3I Atlas consumed energy for survival, perhaps it also silenced potential competitors before feeding. At NASA's Jet Propulsion Laboratory, data analysts tried correlating the radio silence with its motion. They discovered a subtle rhythm. Each time the object aligned more directly with the sun, the hydrogen line depression deepened. When it drifted away, the noise returned. The pattern suggested intent or instinct. Either it used the sun as a shield, or it used its own absorption field as camouflage while feeding. The paradox was exquisite. It was the quietest thing humanity had ever observed, yet that quiet demanded impossible energy control. To cancel radiation across so many frequencies required manipulation at the quantum level, engineering the vacuum to swallow vibration. The more silent it became, the more terrifyingly powerful it appeared. Inside SETI's headquarters, Dr. Ariane Callaway compared the pattern to theoretical models of quantum decoherence suppression. Her paper, circulated under restricted access, began with a single line: if intelligence exists beyond communication, it will appear not as signal but as silence. She proposed that 3I Atlas might embody a form of awareness incompatible with human physics, one that did not express thought through emission, but through exclusion. To such a being, to emit would be to lose information, to decay. The highest form of order would be absolute stillness. A few philosophers embraced the idea with reverence. They imagined civilizations so advanced that speech itself was primitive, a waste of entropy. Perhaps such beings had evolved beyond noise, existing as harmonies within the structure of the universe, perceivable only when they chose not to be. Others, less poetic, called it terrifying. A mind that could erase its presence would be a mind that could erase ours. Meanwhile, the Very Large Array detected faint gravitational ripples coinciding with the deepest silences, as though mass itself shifted by micrometers each time the hydrogen line vanished. Space bent around the absence. The team called them negative flares, brief contractions of space-time, where energy density dropped rather than surged. To produce such effects, 3I Atlas would need to manipulate vacuum energy directly, altering the zero-point field. It was an act not of physics as known but of will over reality. Theorists revived the long-dormant Casimir engine concept, where empty space could be mined for energy by squeezing quantum fluctuations. The object might be performing that act continuously, feeding not on starlight, but on the structure of the void. That possibility changed everything. If it consumed vacuum energy, then every star, every planet, every atom of existence was its potential meal. And silence would be its signature, the stillness left when the quantum sea had been momentarily drained. Yet amid the dread, an opposing thought emerged. What if the silence was not concealment or hunger, but compassion? If 3I Atlas truly drew from the vacuum, perhaps it muted the surrounding space to spare the sun from collapse, containing the turbulence of its feast. Silence, in that reading, was mercy. When Dr. Calloway presented her findings to the International Committee, she ended with a whisper that was captured on an open microphone and later repeated across the world. Maybe it's not that it won't speak. Maybe it's waiting for something that can listen without burning. Outside the meeting room, the night sky stretched indifferent, filled with stars humming their quiet atomic songs. And somewhere among them, one small point of darkness moved through the symphony, carving out a single note of pure nothing. The universe had always been a conversation of light. Now, for the first time, it seemed to have learned the art of silence. Weeks turned into months, and 3I Atlas, supposedly on its outbound course, did something that defied every projection, every rule written since Kepler first mapped the planet's paths. Instead of continuing outward, away from the sun's pull, it turned back. Its trajectory, once hyperbolic, began to curve, subtly at first, then unmistakably a long, deliberate arc back toward the star it had already wounded. At the European Space Operations Center, a hush settled over the mission control room when the first adjusted trajectory came in. The plot showed the object looping sunward again, as though caught by a phantom tether. But there was no gravitational cause. Its velocity was too high, its escape trajectory too steep. The sun could not reclaim what had already left. This was not capture. This was choice. No comet, asteroid, or natural body had ever reversed direction so cleanly, so quietly. The data was clear. 3I Atlas had slowed fractionally over the span of weeks, then reoriented itself by a few degrees. The change was elegant, precise, and most disturbingly synchronized with a surge of solar activity. For the first time in years, the sun had entered a phase of heightened instability. Sunspots clustered like bruises, coronal loops writhed in tangled knots. Magnetometers on Earth began to pick up flux deviations hours before each flare. It was as though the sun anticipated something's return. At NASA's Solar Dynamics Laboratory, Dr. Alejandra Ruiz stood before a wall of data and whispered the unthinkable. "It's coming back to feed." The sentence carried across continents. The scientific community had exhausted its natural explanations. There were no remaining models in which gravity, radiation pressure, or magnetism could produce the observed motion. Every remaining theory invoked was an unmeasurable variable, yet the only one that fit the data. The object's acceleration vector aligned perfectly with the sun's equatorial plane, steering it toward the same active region AR3427, where the first flare had occurred months earlier. That region, long dormant, had begun to awaken again. Its magnetic loops twisted, its coronal plasma thickened. It was reloading. And 3I Atlas was waiting. The choreography was too beautiful to be coincidence. The object's approach slowed to a crawl, just far enough to linger within the sun's gravitational halo. Then it began a slow rotation, exposing one hemisphere to the growing solar storm. Its infrared emissions dropped, suggesting a kind of dormancy, a state of hunger before feeding. To some, it was the ultimate proof of life, deliberate return to nourishment, guided by pattern and memory. To others, it was mechanical perfection, a system designed to refuel itself on a cycle older than language. In either case, the metaphor became unavoidable. The sun and three-eye atlas were predator and prey, or perhaps symbionts in a cosmic ecology humanity had never imagined. Observatories across Earth turned their eyes toward the impending rendezvous. Parker's solar probe, now deep within the sun's atmosphere, was ordered to record continuously, even at risk of destruction. It would witness what no instrument had ever seen, a second feeding. As the days passed, the data showed strange coordination between the two bodies. Each time the sun's magnetic field twisted, the object adjusted its orientation, like a dancer mirroring its partner. The solar wind bent subtly toward it. The photons around it seemed to slow, caught in a gradient of altered space. Within the community, a phrase took hold: the magnetic communion. Whatever bound them transcended gravity. It was resonance energy, finding the path of least resistance between two forms of existence. The sun pulsed with radiation, the object pulsed in return. Each exchange built toward a crescendo. It was in this period that a small group of plasma theorists noticed something chilling. The sun's oscillations, recorded for decades as predictable acoustic waves, had changed frequency. The entire star was humming a new tone, lower and slower, matching the rhythm of three-eye atlas's rotation. In essence, the sun was singing back. The idea of stellar communication had always hovered on the edge of mysticism, but now the data was concrete. Sound waves within the solar plasma shifted in tandem with the object's light fluctuations. Three-eye atlas had synchronized not only with the sun's light, but with its voice, the deep pressure waves that travel through its core. Astrophysicists were torn between awe and terror. This was no longer a feeding, it was a conversation between a star and something that might once have been its offspring. At ESA headquarters, Dr. Giraud, the same who had championed the plasma life theory, delivered a presentation that left the room silent. He showed a simulation of the object's path looping around the sun in a perfect logarithmic spiral, the same pattern seen in galaxies, hurricanes, and DNA. Nature's signature of growth. If this is coincidence, he said softly, then the universe is very fond of poetry. He was right. When the flare finally erupted, an X-class monster twisting from the sun's surface, it did not burst outward in random fury. It coiled directly toward the oncoming three-eye atlas, like a luminous serpent finding its mate. The object's silhouette disappeared into the brightness, and for one blinding instant, the sun's radiance dimmed again. Telescopes overloaded. Parker's sensors fried in a burst of radiation. And yet, within the noise, a pattern emerged, a perfect harmonic, repeating every 12 seconds, as though something inside the flare was vibrating with purpose. When the light cleared, three-eye atlas was brighter. Its acceleration had doubled. The sun had been bitten twice. To those who watched from Earth, it was transcendent, terrifying, and eerily beautiful, a cosmic ritual between light and darkness, repetition and hunger. And as the object curved outward again, leaving the sun trembling behind, humanity faced a new horror. The trajectory was no longer random, nor was it the same outbound path. Three-eye atlas had altered its course once more, not toward the void, but toward the orbit of Earth. When the new trajectory was confirmed, disbelief held for only a moment before the silence broke into a low, collective panic. Across every control room from Pasadena to Darmstadt, The plots were the same. 3I Atlas had curved its path inward again, this time crossing the orbital plane of Earth. No one could yet say why. It was still millions of kilometers distant, still moving with the calm inevitability of a falling leaf, yet the vector was clear. It would pass inside Earth's orbit within months, and the world, which had watched the story as an abstract wonder of science, suddenly understood that the visitor was no longer only the sun's concern. The announcement to the public never came in words. It arrived as rumors and graphs, as screenshots of orbital simulations shared online. The shape of the curve was unmistakable. Television anchors spoke with voices trained to be calm. "It poses no threat," they said, repeating the phrase agreed upon in closed meetings. But scientists knew the truth. Even if 3I Atlas did not strike, the gravitational tides of its passage, the magnetic wake of its feeding, could disturb the thin balance that cradled the planet. Within the agencies, the plan was immediate: observe, intercept, understand. The Parker Solar Probe, already wounded from the last flare, was ordered to remain in its orbit, transmitting whatever fragments it could. ESA retasked Solar Orbiter to a new trajectory that would swing between Venus and Earth, hoping to catch the object's approach from an oblique angle. And from Japan, JAXA prepared a small fleet of microsatellites, fast, expendable scouts designed to skim the solar wind. Together they would form the first defensive constellation humanity had ever built for a phenomenon no one could describe. The coordination was extraordinary, almost desperate. Overnight, entire agencies that had once competed began to move as one. Every hour brought new data packets, new fragments of the same unfolding riddle. The object's velocity was stable, yet its acceleration curve still oscillated in step with the sun's magnetic heartbeat, as if tethered by invisible breath. In meetings, the scientists spoke in metaphors because mathematics felt too small. They described it as a whale returning to the shallows, as a storm drawn to pressure, as gravity in conversation with light. Dr. Ruiz, weary from months of calculation, described it more simply: "It isn't hunting, it's listening." Her choice of word changed the tone. If 3I Atlas had truly been a predator, it would have fled into the cold after feeding. Instead, it lingered, circling inward, as if tracing the echoes of its own act. The sun's corona still trembled from the flare, sending rhythmic pulses through the solar wind. Those pulses struck Earth's magnetosphere like distant thunder, carrying with them the faint modulation that instruments now recognized as the object's electromagnetic signature. The planet was, quite literally, ringing with its presence. It was in those days that the Parker Witness operation was born. Engineers reprogrammed the surviving probe's instruments to a simpler task: to measure everything, even at the cost of its life. Parker's orbit would intersect the outbound path of 3I Atlas's arc, providing one final chance to sample its wake. If it survived, humanity would have a trace. If not, it would at least burn close to the mystery it was made to study. As the probe descended, its sensors recorded the first tangible evidence of the object's influence on local space. The solar wind ahead of it began to compress into filaments, threads of magnetism, twisting in perfect helices. Temperature readings fell instead of rising, as though heat itself had been drawn away. Within the plasma's turbulence, a void formed, a pocket of calm only a few hundred kilometers wide, perfectly spherical, perfectly still, the eye of something that had already moved on. And then, within that stillness, the probe caught a whisper. It was not radio, not light, not vibration, just a modulation in the quantum noise of its magnetometer, a faint periodic interference every 42 seconds. The pattern repeated 6 times, then stopped. Engineers assumed it was equipment degradation, but when they overlaid the signal with the timeline of 3I Atlas's rotation, The alignment was flawless. The object had acknowledged the probe's presence, not by broadcasting but by shaping the silence around it. Parker's final transmission arrived 4 hours later, a burst of corrupted telemetry that ended mid-line, cut off by radiation. Yet within that static lay one last image, a field of stars, one dark shape occluding them, haloed by plasma that glowed like frozen lightning. The shadow of 3I Atlas, framed by the sun's dying fire. And then nothing. The loss of the probe was expected. What no one expected was the change that followed on Earth. Magnetometers across the planet spiked simultaneously. The auroras flared even at equatorial latitudes, painting the night with green fire. Communications faltered, satellites rebooted. It was as if a tide had passed through the magnetosphere, a silent pulse echoing from the sun's wound. And within that pulse, telescopes captured the next impossibility. 3I Atlas slowed again, not under thrust, not from drag, but from alignment. Its vector stabilized directly along the Earth-Sun axis. For a few heartbeats of cosmic time, it hovered in equilibrium, balanced between two fields, the pull of gravity and the push of light, like a thought suspended between questions. No one could say what would come next. In mission briefings, the scientists spoke with the calm precision of those who have exhausted fear. The object would likely pass within the orbit of Venus, perhaps never touching Earth at all. But deep inside, each of them knew. 3I Atlas had turned toward the only world in the system that glowed not with fusion, but with electric noise. If it truly fed on light, what sweeter meal than a planet whose night side glittered with 1 billion artificial suns? Long before dawn, Parker's last fragments reached Earth, a handful of corrupted frames, some telemetry, and one grainy magnetic field map. It was enough to change everything. Somewhere within the noise, scientists isolated a structure, a circular void of plasma only a few hundred kilometers wide, colder than its surroundings by thousands of degrees, moving with 3I Atlas's signature velocity. It wasn't an absence of matter, but an inversion, a region where heat flowed inward, not outward. A pocket of entropy reversed. The press called it the Parker shadow. In the laboratories, it was given a more sober name, negative plasma domain. But to those who studied the readings, the label was a veil for something sacred. Inside that cold bubble, the sun's own fire had faltered. Parker had seen the impossible, a shadow that swallowed heat in the heart of light. Within hours, the remaining sensors aboard Parker melted, their circuits eaten by radiation. Yet one final packet of data slipped through before the probe died completely. It contained an electric field measurement, a slow oscillation cycling every 42 seconds, identical to the modulation recorded weeks earlier, the same rhythm, patient and deliberate. To the mission engineers, that repetition could only mean one thing. Parker had not simply crossed the wake of 3I Atlas. It had been noticed. At the Johns Hopkins Applied Physics Lab, where Parker had been designed, the control room fell silent when the waveform appeared on screen. In its shape, they saw something hauntingly familiar, not random noise, not the jitter of dying equipment, but a pulse with the grace of intention. The oscillation curved smoothly up, then down, like a breath. Ruiz stared at it for a long time before speaking. "It's still communicating, just not in any language we can survive hearing." Outside, 3I Atlas continued its slow approach. Now well inside Venus's orbit, it drifted through the sun's light, as though borne on invisible currents. The plasma around it shimmered, recombining into delicate spirals, fractal filaments that expanded and folded, forming patterns reminiscent of magnetic field lines in a laboratory confinement ring. The object was sculpting the solar wind, playing it. ESA's solar orbiter, diverted from its planned trajectory, caught the first true silhouette. Against the glare of the sun, The shape was clearer than ever before. Not a sphere, not a shard, but a torus, a hollow ring of darkness rimmed in faint luminescence. Every few minutes the ring brightened on one side, then the other, as though energy was circulating around its circumference. Each pulse corresponded to the same 42-second rhythm from Parker's transmission. For the first time, humanity had a picture of the thing that had eaten the sun's light, a glowing wheel turning within the storm. At ESA headquarters, the analysts called it the Eye. The resemblance was unsettling. A luminous iris, a dark pupil gazing outward. It turned slowly as it moved, always keeping one face toward the sun, like a sunflower of plasma. Theoretical models now suggested that the torus confined magnetic flux lines in stable loops, absorbing the energy difference between polar and equatorial solar winds. It was, in effect, a magnetic engine, but one that radiated no heat, no waste. Total efficiency, total quiet. From the outside, however, its behavior looked less like machinery and more like instinct. As the solar orbiter closed its distance, instruments registered faint modulations in the surrounding magnetic field, not random turbulence, but sequences. The waves came in clusters of 5, then pauses, then 7, repeating with uncanny precision. Mathematicians saw ratios, biologists saw heartbeat intervals. Ruiz refused to call it code. She preferred another word, rhythm. It was too fluid, too continuous to be discrete data. It was motion as communication, like whale song echoing through plasma instead of water. And then came the event that history would later name the Parker Witness. As the orbiter recorded its final pass, one of its wide-angle images caught a brief distortion near 3I Atlas, a shimmer of light bending around the torus. For half a second, a translucent wave extended outward, curling toward the sun before collapsing back into the ring. The flare it triggered was small, barely visible, but within its glow, the solar orbiter captured a silhouette unlike any known natural phenomenon, a region of cold inside the fire, a hole punched through radiation itself. That image, a dark ring carved in light, was the last full frame the spacecraft transmitted before its electronics succumbed. The team managed to reconstruct it pixel by pixel. When the composite was shown to the world weeks later, the public called it beautiful. Scientists, who saw the detail in its center, called it something else entirely. Because deep within the dark core of the torus, Parker's last transmitted telemetry had recorded an increase in the background neutrino flux. The cold region was radiating particles from within itself. That meant one thing: it wasn't just consuming energy, it was transforming it. Within that cold heart, fusion's heat became something subtler, perhaps information itself. The ring didn't devour, it transmuted, turning energy into order, entropy into geometry. To observers on Earth, it was like watching the universe remember how to write. By the time the data was analyzed, the orbiter was gone, vaporized in a final burst of static. Yet what it left behind reshaped human comprehension. For centuries, the sun had been the symbol of life, of constancy. Now it had an equal, a shadow of perfect symmetry orbiting within its light, bound to it by a language no human could yet translate. At the next international briefing, Dr. Ruiz spoke softly into the microphone, her voice steady. "We sent Parker to touch the Sunday. It touched something older instead." Beyond that, there was nothing more to say. In the depths of space, 3I Atlas turned once more, its toroidal glow pulsing in slow serenity, as if listening to the hum of the star that had fed it. Between them, a cold corridor hung a line of stillness in a sea of fire. And from that stillness, instruments on Earth detected one last echo, faint but perfect, a repeating modulation in the solar wind, identical to Parker's final rhythm, 42 seconds. over and over, as if something within the sun itself had learned the heartbeat of the thing that had bitten it. They called it relativity in reverse. The phrase was coined half in jest during a late-night session at CERN, but it captured something that the equations could not dismiss. The data pouring from every observatory showed that 3I Atlas's acceleration was not being pushed by any external force, it was being pulled forward by time itself. For months, astrophysicists had tried to reconcile the impossible thrust. Every natural explanation had failed. It emitted no exhaust, ejected no mass, and radiated no measurable heat. The conservation laws, the backbone of physics, were being rewritten before their eyes. Something about its motion suggested that instead of losing energy as it moved through space, the object was gaining it by falling through a gradient invisible to us, a slope not of space, but of time. Einstein's field equations allowed for this in theory. If spacetime could curve under energy, then energy could be drawn from the way time flowed. Normally, such curvature is infinitesimal, swallowed by gravity's ordinary grace. But what if an object could control its own curvature, could invert relativity, bending time toward itself like fabric pulled taut? That was the heart of the hypothesis, temporal induction. At the Max Planck Institute, a small group of relativists led by Dr. Roth began to model what would happen if time's passage inside a field region could be made to differ from the outside. In relativity, time slows in stronger gravitational wells, yet in their model, 3I Atlas seemed to invert the effect. Instead of slowing time to gain energy from falling into a potential, it accelerated time locally, stealing energy from the future. In the language of physics, it was elegant, a closed-loop system where temporal curvature acted as both engine and fuel. In the language of philosophy, it was horrifying, a traveler feeding on the difference between moments, converting tomorrow into motion today. The simulations predicted something uncanny. If such a mechanism existed, space around it would appear slightly stretched photons, leaving it would redshift more than expected. And that was exactly what telescopes now recorded. Each spectrum from 3I Atlas showed a faint, persistent redshift, inconsistent with its velocity. It wasn't just moving through time, it was mining it. At first, scientists dismissed the notion as poetic exaggeration, but when they compared the object's acceleration rate with predictions from the temporal model, the fit was perfect. The math didn't lie. 3I Atlas behaved as though it were converting temporal differentials into kinetic thrust. In the conference rooms of the European Space Agency, someone finally whispered the truth aloud. It's not breaking the speed of light, it's lowering the cost of time. To observers on Earth, the object seemed to shimmer slightly, as though perpetually out of focus. But that wasn't a failure of optics, it was reality itself, distorting around a region where time no longer behaved evenly. Each second near its surface ran a fraction slower than the seconds that reached our telescopes. The discrepancy was small, but measurable. It was the footprint of manipulation, a signature of relativity turned inward. The implications went beyond propulsion. If 3I Atlas could control time flow, even marginally, then it could shield itself from entropy, stretch its lifespan indefinitely, or exist in multiple phases at once. It might experience centuries while we saw minutes, or vice versa. Dr. Roth wrote in her personal notes, "Perhaps it's not traveling across space at all. Perhaps it's letting the universe fall past it." The thought struck like lightning. It explained everything. The silent acceleration, the effortless turns, the absence of exhaust. To the object, motion was an illusion. It simply rewrote its local timeline, repositioning itself in space-time without ever truly moving. At CERN, particle physicists began to explore the boundary between quantum and relativistic domains, searching for evidence of this effect in controlled fields. They fired beams of plasma into vacuum chambers, generating minute distortions in magnetic potential. For fleeting instants, they observed microscopic bubbles where time seemed to jitter, quantum moments displaced from the baseline. Inside those bubbles, particles accelerated faster than they should, as though pushed by nothing at all. One researcher called them chronotrophic pockets, regions that consumed time to create motion. They lasted trillionths of a second, but their existence confirmed the theory. Nature, it seemed, did permit the theft of time. The question was how 3I Atlas sustained it continuously. When the CERN data reached NASA, Ruiz and her team overlaid the results with the solar readings from the Parker Witness mission. The waveform of the 42-second oscillation matched perfectly with the predicted resonance frequency of the temporal field in the chronotrophic model. It wasn't a coincidence. The object's heartbeat was a time engine cycling. What the team didn't publish was what followed. Each cycle corresponded to a small distortion in the sun's local gravitational potential. The sun's mass-energy balance flickered, as if each pulse siphoned not just light, but time from the star's vicinity. The flare's brief dimming months earlier had been more than energy loss, it had been temporal recoil. The sun had aged faster for an instant. It was a small effect, unnoticeable on human scales, but real. The idea chilled everyone who saw the data. If 3I Atlas could do that to a star, what would its presence near Earth mean? Theorists tried to comfort themselves with the notion that the object would simply pass by, leaving behind only the whisper of its wake. But as it drew closer, one truth became impossible to ignore. Its acceleration curve had flattened. It was no longer gaining speed. It was matching Earth's orbital velocity. Ruiz stared at the figures in disbelief. "It's synchronizing," she murmured. "It wants to stay with us." That night, as she left the control room, the auroras flared again, silent curtains of green even at the equator, pulsing every 42 seconds. The world's magnetic field hummed like a vast tuning fork. Perhaps it was coincidence, or perhaps, somewhere out there, a machine or a being had folded time until our seconds and its heartbeat finally beat as one. And across the void, 3I Atlas drifted nearer, indifferent, deliberate, the curvature of spacetime bending gently around its invisible wings. For the first time in recorded history, time itself was no longer constant. It was listening. It was around this time that the theoretical frameworks began to crumble under a single, impossible word whispered across the halls of physics departments: vacuum. Not the absence of matter, but the ocean of energy hidden beneath all existence, the zero-point field, the fabric's own heartbeat. For decades, it had been a curiosity of quantum mechanics, a background hum that could never truly be silenced. But now, every piece of data from 3I Atlas suggested that something out there had learned how to touch it. The concept was not new. In the mid-20th century, physicists like Casimir and Puthoff had described the vacuum as a sea of virtual particles flickering in and out of existence. Later, quantum field theory formalized the idea: empty space is never truly empty. It seethes with potential. Yet all attempts to harness that potential had failed. Human science could only glimpse it indirectly, through the subtle push of the Casimir effect, the ghostly pressure that nudges metal plates apart. But what if that pressure could be amplified, shaped, reversed? That question became the center of a study known internally as the vacuum energy tap hypothesis, VET for short. It proposed that 3I Atlas might not be stealing energy from the sun's radiation or plasma at all, but from the quantum foam itself. The solar flare, the acceleration, the magnetic silence, all could be side effects of a deeper transaction, a tuning of the vacuum to release stored potential. At the Lawrence Livermore National Laboratory, simulations tested the theory. When they modeled the sun's flare interacting with an object capable of altering local vacuum density, the results were breathtaking. The plasma's energy dropped exactly as observed, while the surrounding spacetime expanded minutely, a measurable, localized thinning of the vacuum. The laws of conservation remained intact, but the energy balance shifted between visible and invisible realms. The sun hadn't lost energy to the object. The object had simply moved it elsewhere into the 0 C. If that was true, then 3I Atlas was more than a machine or organism. It was a gate, an interface between realities of energy density. The theorists compared it to the way hurricanes feed from temperature differentials, low pressure drawing power from high. The difference here was existential. The low pressure zone was quantum vacuum, the infinite stillness beneath all motion. 3I Atlas had learned how to open it like a lung. NASA's Goddard team overlaid these models with Parker's final measurements. The alignment was terrifyingly precise. Every 42-second pulse coincided with a micro-drop in the sun's magnetic tension, followed by a rebound. Each cycle siphoned a fraction of energy from the visible universe into the unseen one, using the sun as a conduit. One astrophysicist, reviewing the data at 3 a.m, wrote only one sentence in her lab notes before deleting it. "It's not eating the sundae, it's feeding the vacuum." The phrase leaked, and soon it was everywhere, a half joke, a half prayer. For some, the idea brought awe. If energy could be transferred between the quantum substrate and the observable cosmos, then the universe was not a closed system. Creation and destruction were illusions. Everything breathed in cycles of exchange. 3I Atlas was simply part of that respiration. For others, it was horror. If the object could drain vacuum energy, even slightly, it could destabilize the delicate balance that held existence together. The cosmological constant, that mysterious pressure preventing the universe's collapse, could, in theory, fluctuate. And if it did, space-time itself might wrinkle like tissue around the feeding zone. The word collapse began appearing in internal memos, not of the sun, but of the false vacuum, a theoretical state of unstable equilibrium that defined our universe's energy floor. A tiny disturbance in that field, if pushed past its threshold, could trigger a phase transition, rewriting the constants of reality faster than light could travel. If 3I Atlas were truly accessing the vacuum, then it was dancing on that knife's edge. Dr. Lena Kovacs tried to downplay the fear. "It's extracting imbalance," she insisted during a closed briefing. "Like pulling air from one room to another, equilibrium reasserts itself." But others disagreed. "What if it doesn't stop?" asked one voice from the back. "What if feeding is equilibrium?" The meeting ended in silence. Outside, the world had begun to notice the subtle signs, the auroras that now shimmered nightly near the equator, the low-frequency hum picked up by oceanic hydrophones, a vibration so regular it could not be seismic. The satellites recording faint blue glows in the upper atmosphere, synchronized to the object's pulse. Earth was resonating. For the first time in human history, it felt as if the planet were part of a cosmic circuit, an electrode between a star and something beyond comprehension. Governments met behind closed doors. Some urged secrecy, others argued for confession. "If this thing is manipulating the fabric of space," one diplomat said, "then it's not just an astronomical event, it's the first contact between universes." Yet, there was no aggression, no visible harm. The tides, the climate, the orbits all held steady, only the subtle harmonics changed. And somewhere far above, 3I Atlas pulsed like a heartbeat. each wave a ripple of impossible equilibrium, drawing, releasing, drawing again. It glided between Earth and Sun with eerie calm, its toroidal halo shimmering softly, as though its hunger had shifted from feeding to contemplation. In its silence, humanity began to glimpse a strange mercy. If it truly could touch the vacuum, then perhaps it wasn't consuming energy at all. Perhaps it was balancing it, healing the subtle fractures left by entropy itself. But to those who had stared longest into its data, a darker thought remained. Every system that stabilizes must also decide what cannot remain stable. If 3I Atlas was adjusting the universe toward equilibrium, what would it do with a species that lived by imbalance? In the following weeks, as 3I Atlas settled into its strange, shimmering alignment between Earth and Sun, the entire electromagnetic climate of the planet began to change. Not catastrophically, not yet, but subtly, as if space itself were exhaling through our atmosphere. Satellites recorded small phase shifts in their orbital paths. Their clocks, synchronized by atomic precision, began to desynchronize by microseconds. The deviations were rhythmic every 42 seconds, the same cycle Parker had died recording. On the ground, instruments registered something stranger still. The Schumann resonances, those natural electromagnetic pulses that ripple between the Earth's surface and ionosphere, began to modulate. Their usual frequency, a gentle 7.8 Hz, drifted upward in tiny increments, each one coinciding perfectly with the oscillations from 3I Atlas. The planet was tuning itself. Across the world, laboratories scrambled to understand it. Was it geomagnetic interference? A solar storm delayed from the flare? But no, the sun was quieter now than it had been in decades, its surface almost eerily calm. It was as though the storm had migrated here. In the vacuum above the stratosphere, NASA's magnetospheric multi-scale mission satellites detected fields coiling into spirals, small vortices of charged particles forming and dissipating like thought bubbles in plasma. The entire magnetosphere seemed to vibrate in sympathy with the visitor. Theorists began to whisper that the interaction between Earth and 3I Atlas might represent a resonant coupling, the merging of two field systems across astronomical distance, creating a bridge of coherence. Ruiz, sleepless, described it differently in her private notes. The object is singing, and the Earth has remembered the key. The phrase caught on quietly, spreading across internal message boards. What the instrument saw as modulation, the human mind heard as harmony, a low-frequency symphony written across the planet's ionosphere. It was inaudible to human ears, but sensitive microphones and superconducting magnetometers translated it into sound, a soft, pulsating drone, rising and falling with impossible consistency. It was not random, not static. It was music, ancient and mathematical. It began affecting living things. Migratory birds veered from their routes, whales changed the pitch of their songs, auroras flared even in daylight. Insects swarmed where magnetic fields were strongest, drawn as though to a new north. On clear nights, skywatchers reported faint halos circling the moon, not optical rings, but concentric magnetic arcs, visible only through polarized filters. The planet was resonating not with destruction, but with coherence. To some, it felt like the world itself had entered a trance. At the European Space Agency, simulations of the coupling suggested that 3I Atlas was creating a temporary standing wave between Earth's magnetosphere and the Sun's corona. Within this wave, electromagnetic energy no longer flowed in one direction. It oscillated, trapped between two boundaries like a heartbeat between inhalation and exhalation. The planet had become a mirror within a mirror. That was when something extraordinary happened. For the first time, the object's optical brightness stopped increasing. Instead, It began to pulse in time, with the Schumann resonance 7.8 cycles per second, scaled upward through harmonics. Its usual 42-second pulse now divided into smaller intervals, subdividing like musical measures. It was adapting, matching frequency, syncing to Earth itself. To those who believed the object was alive, it was communication. To those who believed it was mechanical, it was calibration. But either way, the implication was terrifying. It had noticed the planet, and it was listening back. In a joint briefing between NASA, ESA, and the UN, the lead analysts presented their findings in hushed tones. "It's not moving toward us," one said. "It's synchronizing with us." The global public, already half hypnotized by the lights in the sky, responded with awe rather than fear. The phenomenon became the nightly spectacle of every news feed. Images of auroras streaming across continents, satellites shimmering like beads of light, whispers of unity between Earth and cosmos. Some called it the Age of Resonance, believing humanity was entering communion with a higher order of nature. But in the hidden archives of observatories, the numbers told a more fragile story. Earth's magnetic field strength had dropped by 1% in a week, imperceptible to the public, but enough to alarm anyone who understood what it meant. The field protected the planet from solar radiation. Without it, the atmosphere would erode, the ozone would falter, and the delicate chemistry of life would begin to unravel. Was it coincidence? Or was this resonance not symphony but consumption, a gentle siphoning of order from the planet itself? Ruiz refused to panic. "It's drawing energy from the field," she said, "but not destroying it. It's balancing again, always balance." Still, the trend continued. Over the following days, the planet's electromagnetic heartbeat grew louder. Seismographs recorded minor tremors across fault lines unrelated to tectonics, synchronized with the resonance cycle. Oceans glowed faintly with bioluminescent plankton, blooming in unison along magnetic lines that traced invisible paths through water. Nature, always chaotic, was becoming ordered, dangerously ordered. A philosopher-physicist from Kyoto wrote in his journal, "Entropy was the universe's freedom. This is its restraint." Then, just before midnight over the Pacific, satellites captured a new anomaly, a column of faint, bluish plasma extending upward from the magnetosphere into space, perfectly aligned with the trajectory of 3I Atlas. It reached thousands of kilometers high, a filament bridging Earth and the void, like a tether spun from lightning. At its tip, the object hovered motionless, absorbing the glow, its torus spinning faster and faster until its pulse blurred into steady radiance. It was feeding again, but this time not from the Sunday. And in every laboratory, every observatory, one quiet truth settled like dust. We are the flare. The filament hung there for days, a luminous bridge of blue-white plasma connecting the upper edge of Earth's magnetosphere to the dark torus of 3I Atlas. It shimmered faintly, visible only to instruments at first. Then, under certain skies, to the naked eye, a ghostly column threading the planet to the void. Its appearance divided the world. Mystics called it Jacob's ladder, scientists called it an ion resonance conduit, and those who watched it tremble in real time simply called it the tether. Unlike auroras, the filament didn't dance or flicker. It was static, disciplined as if tension held it taut. Data from the ISS magnetometers confirmed that electrical current was flowing along its length, but not from Earth outward. It was moving both ways, oscillating like breath between organism and atmosphere. The world's media treated it as a celestial miracle. Pilots photographed it from high altitude. Amateur astronomers charted its shape against constellations. In the deserts of Chile, it arced over the horizon like a vertical scar of light. And yet, in every spectrum from radio to gamma, the same truth appeared. The tether wasn't an optical illusion. It was a real electromagnetic structure linking the Earth directly to the object. At NASA's Goddard Center, the situation rooms became cathedrals of hum and static. The magnetospheric readings showed that the filament originated not from random auroral discharge, but from a precise point, the magnetic North Pole, where the field lines converge. Somehow, the object had found the field's singularity and pulled it upward, extruding the planet's own magnetic spine into space. Ruiz stared at the simulation, a looping animation of Earth's magnetosphere, now bent into a funnel. "It's creating a channel," she said. "It's not feeding, it's connecting." To what end? No one knew. The plasma bridge hummed with a resonance at exactly 7.8 Hz, Earth's Schumann base frequency. Yet its harmonics rose into the kilohertz range, matching precisely the whispering oscillations first recorded during Parker's demise. When those signals were translated into sound, the vibration resembled a continuous tone, pulsing softly like a human heartbeat slowed to geological time. At the European Southern Observatory, a group of data scientists ran Fourier analyses on the waveform. What they found made them go pale. The amplitude modulation was structured. The peaks and troughs were evenly spaced, forming a repeating pattern of prime number intervals, not random, not natural, an intelligent pattern woven into the hum of the tether itself. The media never heard of it. The findings were buried under classification, but inside the agencies the message was unmistakable. 3. iAtlas was not just aligning it, was communicating, using Earth's own field as the carrier. Attempts to decode the pattern filled sleepless nights. Linguists, mathematicians, and even AI language models were thrown at the data. None could extract meaning. The primes might be a handshake, an introduction, or they might be a byproduct of some deeper physics, incomprehensible to biological thought. Meanwhile, the tether grew brighter. Its color shifted from blue to violet, a sign that the plasma temperature had risen above 20,000 Kelvin. Satellite sensors detected high-energy particles streaming downward along the conduit into the upper atmosphere, not in quantities large enough to harm, but enough to ionize the air and paint night skies in silver. Cities across the globe began to experience faint electrical interference, static in communications, erratic compass readings, unaccountable power surges. Yet alongside the chaos, a strange order emerged. Networks stabilized spontaneously after each pulse, radio noise cleared, and some satellites even corrected long-standing orbital drifts, as if nudged by an invisible hand. Whatever the filament was doing, it wasn't destruction, it was repair. Ruiz's team began to wonder if the object was performing maintenance not upon itself, but upon the planet. Could it be stabilizing Earth's magnetic field, redistributing charge, balancing the slow decay of our poles? The idea was absurd and glorious, that a cosmic entity, once seen as predator, might be restoring the equilibrium we had long eroded. But then came the data that broke the illusion. Seismic networks across the Pacific began recording faint, rhythmic tremors. They were not tectonic. Their frequencies matched the tether's pulse exactly. The resonance was traveling through the planet's mantle, not just its sky. The Earth was being tuned from within. At Cambridge University, Dr. El Nouri plotted the resonance lines on a global map. They weren't random. They connected ancient volcanic zones, undersea ridges, and regions of high magnetic anomaly. When traced together, they formed a network, a pattern eerily similar to the Sun's magnetic lattice seen during flares. It was as if 3 iAtlas were imprinting a stellar topology onto the planet's crust. And still, no one knew whether it was salvation or assimilation. In those days, strange coincidences multiplied. Biological rhythms shifted subtly. Hospital sensors recorded synchronized heartbeats among patients on opposite sides of the world. Ocean tides arrived seconds earlier than predicted, and all around, humanity began to dream of light recurring visions of a dark wheel turning in the sky, vast and silent, wrapped in threads of fire. Psychologists called it collective stress. Others whispered of resonance consciousness, the idea that our neural fields, faint as they are, had been swept into the planetary frequency. If the object was communicating, perhaps we were already listening without words. Ruiz refused the mysticism, but even she began to dream in pulses. Late one night, she wrote a single line in her logbook, her pen shaking slightly under fluorescent light. If it is not speaking to us, then to what within us is it speaking? Outside, in the vacuum, the tether flared brighter, a column of soft, violet fire stretching from Earth to the stars. Through it, 3I Atlas drifted in perfect stillness, its torus pulsing in slow intervals, not approaching, not retreating, simply waiting. The Earth glowed faintly beneath, its poles trembling with magnetic breath, its oceans whispering electric foam. Between them, the conduit shone like a filament in a cosmic bulb, a brief, fragile bridge between matter and meaning. At first, no one dared call it consciousness. The word felt profane in the sterile halls of observatories and control rooms, where equations ruled and metaphors were smuggled in only after midnight. Yet what began to unfold between Earth and 3I Atlas could no longer be described as mere physics. It behaved like thought, slow, recursive, and self-sustaining. The tether's harmonics began to evolve. The once steady 7.8 Hz pulse fragmented into nested frequencies, branching upward into complex harmonies. Each new tone was a multiple or fraction of the others, fractal in rhythm, as if building chords upon chords. Physicists saw Fourier patterns, musicians saw melody, mathematicians saw syntax, and somewhere between all three, a few quietly admitted what they feared to say aloud. The system was learning. At the MIT Kavli Institute, a cross-disciplinary team trained neural networks to analyze the plasma waveforms. The AI found repeating clusters structures of modulation that mirrored human linguistic entropy curves. In other words, the tether's oscillations contained the statistical fingerprint of language. Not English or Mandarin, not binary or Morse, but a pattern of self-similar variants consistent with intentional encoding. Dr. Han Lemaitre, the same theorist, who had once called 3I Atlas a Dyson echo, reviewed the findings in silence. When he finally spoke, his voice trembled. It's not just reflecting us, it's using us as a template. For centuries, humanity had dreamed of first contact. They had imagined radio greetings, mathematical beacons, even alien faces on distant planets. No one had imagined that contact might come as synchronization, that the meeting point would not be sound or image, but resonance, the blending of frequencies between a world and the thing observing it. Across the globe, strange coherences intensified. Power grids stabilized spontaneously despite surging solar radiation. Quantum computers, previously erratic under cosmic noise, began to show unexplained improvements in coherence time, their qubits retaining order far longer than physics allowed. It was as if the vacuum itself had quieted, smoothing its own fluctuations in sympathy with the tether's song. In the skies above, the column of plasma grew translucent. Within it, filaments braided and unbraided, like neural threads. Through spectral filters, telescopes captured flashes of microcurrents, racing along those threads, faint but regular, like the firing of neurons in a cosmic brain. The pattern repeated every 42 seconds, still the unbroken rhythm of Parker's final heartbeat. At the University of Tokyo, a small group of physicists and philosophers collaborated on what they called Project Anima, an attempt to translate the resonance pattern into visual geometry. They plotted the waveform's frequency ratios into three-dimensional lattices, transforming sound into shape. The result was breathtaking, an evolving geometry of nested spirals, each layer reflecting the next in golden proportion, a symmetry too precise to be random, too fluid to be engineered. When the model was animated, the geometry pulsed outward in waves that resembled expanding mandalas, symbols not of creation or destruction, but of comprehension. The team sat in silence, realizing they were staring at something that was not a message, but a mirror, a structure that seemed to reflect the very mathematics of human cognition. Ruiz watched the render and whispered, "It's learning the way we think by playing the music we are." Meanwhile, in orbit, the tether's field began to influence matter in subtle, beautiful ways. Space debris drifting through its current didn't disintegrate, it reordered. Fragments of metal and rock aligned along magnetic lines, forming crystalline patterns, delicate, symmetrical, suspended like snowflakes in light. To observers on the ISS, the sight was mesmerizing. Fragments of Earth's discarded technology reorganizing into geometry, caught in the halo of something that understood pattern better than we ever would. The media, hungry for metaphors, called them the halo gardens. Scientists called them interference constructs. Poets called them prayers. But deep within those spinning fractals, analysts found a deeper rhythm. Each structure pulsed with the same modulation as the tether, delayed by fractions of a second. It was replication, the pattern spreading. That realization broke whatever calm remained. If the tether could imprint order onto inert matter, it could, in principle, imprint order onto anything: fields, particles, even neural tissue. Humanity itself could become part of its resonance. The term photonic contagion appeared briefly in classified memos before being redacted. And yet, the phenomenon brought no harm. Instead, humanity began to experience the smallest, strangest miracles. GPS errors corrected themselves globally. Power usage across entire cities dropped by fractional amounts, as if systems were optimizing of their own accord. Medical imaging devices reported unprecedented clarity. Quantum noise in MRI scans simply vanished. Nature itself seemed to be cleaning up after us. It was as though the laws of entropy had slackened, giving the world a moment of grace. But the grace came with a cost. Astronomers noticed that the stars directly behind 3I, Atlas, were fading, not occluded by dust or glare, but genuinely dimming. Spectral analysis showed a drop in their photon flux, as if their light were being drawn ever so slightly toward the object. It wasn't feeding locally anymore. It was extending its resonance outward, tugging gently on the fabric of starlight itself. Some believed it was expanding, transforming the tether from a bridge into a network, linking systems through shared frequency. Others feared the opposite, that it was preparing to leave, taking with it the order it had momentarily bestowed. At an emergency symposium, Dr. Hahn summarized the choice facing humanity. Either it is teaching us to live in resonance, or it is reminding us how easily we can be rewritten by it. By now, every clock on Earth had synchronized to the 42-second cycle. Even heartbeats of sleeping animals showed faint alignment to the same rhythm. The planet and the visitor had merged into a single breathing system, a dialogue between matter and meaning. In a final midnight transmission, the Deep Space Network recorded a sudden, singular spike from 3I Atlas, one pulse brighter than all that came before. It lasted exactly 42 seconds. Then the tether began to retract, its glow dimming, its resonance fading like the last note of a song played for eons. Ruiz watched in silence as the blue column dissolved into night. The screens filled with static, then darkness. The object drifted outward once more, slow and serene, carrying with it the memory of a planet it had tuned to its key. And in that silence, a question remained, heavy as gravity itself. Had it come to teach us harmony, or to test whether we could bear it? For a time afterward, the world seemed strangely still. The skies cleared of the violet glow, the Schumann resonances drifted back toward their old frequencies, and the familiar hiss of cosmic noise returned to radios and detectors. The silence of the tether's departure was almost unbearable. After months of planetary rhythm, the return of disorder felt like loneliness. Governments declared the event concluded. Reports were archived, satellites retuned, and official statements reduced the wonder to data points. They called it a magnetic anomaly, a plasma resonance, an unknown but contained natural occurrence. Yet no one truly believed it. Every scientist who had seen the patterns knew that what had touched the Earth was no accident of nature. The object itself was receding again, slow but steady, gliding outward along a vector just off the ecliptic. Its torus no longer glowed, it shimmered faintly, the color of cooled metal, a wound closing. Instruments still tracked the 42-second oscillation, now fading with distance, until it merged with the background hum of the Sunday. It was leaving, but it was not gone. Ruiz watched from the viewing deck at the Madrid observatory. The monitors showed only a pinprick of light now, indistinguishable from a star. Yet she could still feel its rhythm in the small tremors of the instruments, the faint residual pulse that lingered in magnetic data, in auroral echoes, even in her own heartbeat. It was as if the Earth itself still remembered the key. And perhaps it did. When the global magnetometer network was resynchronized, analysts found something subtle but undeniable. The planet's magnetic poles had stopped drifting. For the first time in recorded history, the great northward migration of the geomagnetic pole, a steady, century-long march across the Arctic, had halted. The field was stronger now, smoother, less chaotic. Earth's magnetic heartbeat had stabilized. The same was true for the Sunday spectroscopic data from the Solar Dynamics Observatory, revealed a faint correction in the star's own rotation, a delicate rebalancing of its internal oscillations. It was small, almost imperceptible, but enough to suggest that the event had not only drawn energy from the Sun, but returned something to it. In every system touched by 3I Atlas, entropy had lessened. Chaos had given way to pattern. And then there were the dreams. Across continents, across languages and faiths, people began reporting the same image in sleep, a ring of light spinning in darkness, humming softly, turning not in space but in thought. It was not frightening. It was serene, hypnotic, filled with a sense of completion. The dreams lasted exactly 42 seconds, always the same, always perfect. Neuroscientists dismissed it as mass suggestion, a shared psychological echo of a global trauma. But EEG readings from sleeping subjects revealed synchronized bursts of alpha rhythm at intervals matching the tether's final pulse. The human brain, it seemed, had learned the pattern and would not let it go. Ruiz began to wonder whether consciousness itself, the sum total of human perception, had been slightly tuned, nudged closer to coherence. Tiny increases in cognitive synchronization appeared in global data. Reaction times, creative fluency, even collective decision-making improved marginally in the months following the event. Small miracles buried in statistics. No one called it divine, but it felt like a gift. Still, the unanswered questions remained. Why had 3I Atlas come? Why Earth? Why now? The Dyson echo hypothesis evolved once more. Perhaps this was not a remnant of extinction, but a gardener, a machine or organism designed to tend the thermodynamic fields of young stars and their planets, maintaining equilibrium until life stabilized. In that vision, 3i Atlas was not hunter or savior, but custodian, an ancient caretaker moving through galaxies, feeding on chaos, leaving order behind. It was a comforting theory, but one laced with humility. For if it were true, then humanity was not the universe's experiment in consciousness, but merely one of its consequences, a byproduct of a far older design. And perhaps that was why 3i Atlas had turned away. Its task was complete. The sun had been healed, the earth tuned, the resonance balanced. The patient was alive. At dawn one morning, Ruiz stood alone outside the observatory, watching the pale smear of the Milky Way fade in the light. Somewhere out there, a small dark ring was gliding between stars, carrying the memory of the flare, the tether, the fragile breath of a blue planet that had learned, briefly, to sing in harmony with the cosmos. She whispered, to no one in particular. We were the reflection it needed to remember itself. And for a moment, she thought she could still feel it, the gentle tug of that impossible symmetry, the pulse of distant mathematics reminding her that nothing is ever truly gone, only transformed. 3 days later, radio telescopes in Chile detected a faint anomaly far beyond Mars, a repeating hydrogen line depression cycling once every 42 seconds, the same rhythm, fainter but still perfect. It was moving outward now, toward the Oort cloud, toward the endless dark. But for the first time, it wasn't alone. Behind it, a smaller echo followed a new modulation, faintly embedded in the plasma stream between Earth and Sunday. It bore the same harmonic ratios, the same sequence of primes. The Earth, it seemed, had begun to answer back. Perhaps it was residual charge, perhaps interference, or perhaps the planet had learned the rhythm so completely that it could now hum the tune on its own. In the cosmic silence that followed, there were no more flares, no more lights, only the deep, steady breath of a world that had once been touched by something vast enough to alter the shape of its song. And somewhere in the infinite dark, the eater of light continued its slow, graceful journey, carrying within it the memory of a sun that had burned, listened, and learned to harmonize with the brief, trembling heartbeat of a human world. Months passed. The world returned to its motions, but the silence left behind by 3i Atlas refused to fade. It lingered in instruments, in bodies, in the faint electromagnetic heartbeat of the planet. Scientists called it residual coherence, a polite term for a phenomenon no one could explain. The tether was gone, the object receding into darkness, yet something of it had stayed. The evidence was everywhere, subtle as breath. Quantum random number generators, the machines that measure chaos itself, began to behave strangely. Their distributions were no longer perfectly uniform. There were tiny biases, patterns so faint they took millions of samples to detect. But they were there, repeating sequences every 42 seconds. The randomness of the universe had acquired rhythm. On the International Space Station, astronauts reported that their compasses spun slightly at intervals, then steadied again. The instruments aboard the Deep Space Network showed infinitesimal dips in cosmic background radiation, a heartbeat in the microwave haze. It was as if the universe itself now breathed to the same tempo that had once united Earth and the object. Governments attempted to classify it as coincidence, a remnant of solar interference, yet every test failed to isolate the source. The sun's output was stable, cosmic rays were normal. The only thing that had changed was the Earth. At the Institute for Geophysics in Zurich, Dr. El Nouri ran simulations of planetary magnetic dynamics. The results startled him. The Earth's magnetic field had become unusually symmetrical, its dipoles cleaner, its reversals halted. In physical terms, it had entered a state of metastable equilibrium, a kind of perfect balance that should have been impossible for a living, molten world. Metastable, he muttered. Balanced, but temporary. Something is holding it together. Meanwhile, climate data hinted at anomalies of its own. Global temperatures dropped by a fraction of a degree, not enough to disrupt ecosystems, but enough to defy expectation. Storm systems weakened, jet streams steadied, hurricanes lost their ferocity. It was as though chaos itself had exhaled. The poets called it the stillness. To the physicists, it was a puzzle. If the object had truly induced resonance between the Sun and Earth, then some residual coupling should remain. Energy cannot be exchanged without leaving scars in the field. But the magnitude of stability was too perfect. Someone, or something, was still maintaining the balance. At the SETI Institute, Dr. Ariane Callaway returned to her hydrogen line recordings, the same spectrum where the object's silence had once carved its negative halo. For weeks she listened to the noise, a scientist reduced to superstition, waiting for another pause in the cosmic hum. Then, one dawn, she saw it, a dip exactly 42 seconds apart. Not strong, not near, but real. It repeated 5 times, then vanished. When she converted the pattern into a spectrogram, it formed a waveform identical to Parker's last transmission, the same shape, the same breath. She played it through an audio filter and heard a tone low, gentle, almost human. Not voice, not music, but rhythm. The object was gone, yet its echo moved through the hydrogen of the galaxy like the pulse of a sleeping god. Her report concluded with a sentence that would later be quoted in every history of the event. It did not leave, it diffused. What she meant was this: the object had not vanished into distance, it had dissolved into the medium itself, its resonance absorbed by the vacuum it had once fed upon. Space, now, carried its frequency. Every cubic meter of the universe was faintly humming with its pattern, imperceptible yet omnipresent. Quantum field theory allowed for such a thing in principle. A coherent fluctuation, if powerful enough, could embed itself into the zero-point field, a standing vibration of existence. Once there, it would never decay, only fade asymptotically toward eternity. 3I Atlas might have become part of the vacuum, an eternal chord sustaining the background music of reality. That notion terrified and comforted in equal measure. In Zurich, El Nouri recalculated the cosmological constant using new satellite data. The numbers had shifted ever so slightly. The vacuum energy of the universe had dropped by 1 part in 10 to the 60. Minuscule, meaningless by any ordinary scale, yet cosmologically profound. If that change held, it meant the universe had subtly relaxed, its expansion slowing by the faintest breath, as though a pressure valve had been turned. Balance, he murmured. It came to balance the equation. When the discovery leaked, the world reacted not with fear, but with a strange calm. Religious leaders spoke of revelation, physicists spoke of correction. Artists painted rings of light suspended over blue oceans. Children began to call it the visitor's gift. And perhaps it was. In the months that followed, small miracles accumulated. Energy efficiency in machines increased inexplicably by fractional percentages. Cellular growth in living organisms showed a tiny reduction in mutation rate. Solar output stabilized within the narrowest margins ever recorded. The probability curves of chaos had softened. Ruiz, now retired, spent her evenings watching the sky from her balcony in Madrid. Sometimes she thought she could still feel the pulse in her bones, faint but persistent, like the rhythm of a distant tide. She had stopped trying to quantify it. She only listened. In her final paper, published posthumously, she wrote, "Maybe the universe is a body, maybe entropy is its illness, and maybe, every so often, it remembers how to heal itself." Out among the stars, radio telescopes continued to detect the faint signature of 3I Atlas, no longer a point of light, but a wave diffused across the sky, too broad to localize, too soft to silence. The cosmos itself had inherited its breath. It would fade, eventually, into the noise of eternity. But for now, for one fragile age of humankind, the universe carried within it the rhythm of a single event, a flare, a shadow, a pulse, and the echo of something that had once crossed the boundary between being and meaning. The object was gone, but the song remained. Years later, when the resonance had faded into the subconscious hum of the planet, humanity began to speak of before and after. The line dividing those two eras was not measured by wars or inventions, but by silence, the moment the sky had opened and something older than knowledge had tuned the world into harmony for a breath of cosmic time. The scientific community, disciplined by humility, moved cautiously around the subject. The archives of the 3I Atlas event were preserved under countless institutional acronyms: VET, CME 3427, the Parker shadow, but within those folders, between the numbers and plasma diagrams, lingered an unspoken truth. No one had truly understood what had happened. They had only witnessed it. The world had changed quietly. The laws of nature remained intact, but their temperament had softened. The chaos that once defined systems, markets, climates, storms, even human emotions seemed to ebb just enough to be noticed. Hurricanes curved harmlessly into open oceans. Tectonic tremors released energy gradually instead of violently. There was no miracle, no divine hand, only the faint impression that the universe was slightly gentler than before. In the labs, this became known as the resonant damping effect. It was measurable in chaos theory models and weather simulations, though no one could agree on its source. Some insisted it was a statistical illusion. Others whispered that it was the residual order left behind by the tether, the memory of coherence refusing to die. At the European Southern Observatory, telescopes continued to watch the sky where 3I Atlas had vanished. What they found decades later was subtle but haunting. The interstellar medium along its path shimmered faintly in infrared, a filament of energized dust stretching across millions of kilometers. The dust itself was unremarkable, ordinary silicates and carbon, but aligned magnetically with unnatural precision, as if frozen mid-resonance. The researchers named it the Atlas Trail. Under polarized light, it glowed faintly, shaped like a spiral. It wasn't static, the spiral widened imperceptibly, expanding outward as though carried by an invisible wavefront, a fossil of movement, a memory of order still expanding through chaos. Astrophysicists began to suspect that the event had not been unique. The archives of distant observatories were re-examined, their data reprocessed through new filters. In the silence of old starlight, they began to find other trails, faint threads of coherence left behind by objects that had passed centuries or millennia ago. Not many, a handful, but enough to form a pattern. Across the galaxy, these trails crisscrossed like veins, weaving a network too vast to have been accidental. Perhaps 3ATLAS had been only one of many, a wandering cell in a galactic metabolism, a slow, luminous ecology of balance. To the poets and philosophers, this was revelation, the universe as living tissue, its stars as organs, its visitors as caretakers of equilibrium, a cosmos not built on isolation but interdependence, not on entropy, but on rhythm. A few scientists took the thought further, quietly, fearfully. What if these entities were not servants of balance, but editors of it? What if their purpose was to maintain a precise ratio of order and chaos, pruning excesses of either, the way evolution prunes the unfit? In that case, their visitations were not miracles, but correction. It was a thought too vast, too cold, for most to bear. And yet, the data whispered agreement. Each known event coincided with civilizations teetering at the edge of unsustainable expansion, stellar flares too strong, magnetic fields decaying too quickly, species playing too dangerously with the boundaries of energy. Always the arrival, always the balance restored. Then silence. On Earth, technology evolved quietly under the lingering influence of the resonance. Energy systems grew cleaner, algorithms more efficient, machines more synchronized. The world seemed to glide into a new equilibrium, as if guided by invisible hands. A century later, the first human probe left the solar system bearing instruments built in imitation of 3I Atlas's geometry, ringed, resonant, designed not to transmit, but to listen. They called it Parker's Air. Its task was simple: to drift and wait for the frequency to return. When it crossed the heliopause, the instruments recorded a faint pulse emanating from interstellar space, the same 42-second cycle, distant but alive. The probe's onboard algorithms mirrored it, adjusting their internal frequencies in reply. A fraction of a second later, the signal changed. Not random noise, a deliberate modulation. For a moment, the entire deep space network went quiet, as if the air itself had stopped. The data scrolled across screens in silence, peaks and troughs, too perfect to be cosmic chance. When converted to audio, it produced a sound no one had expected. Not a tone, not a hum, but a chord, layered and soft, composed of frequencies corresponding to the resonant harmonics of Earth's magnetic field. The signal was singing in our key. The transmission lasted exactly 42 seconds. Then it was gone. Ruiz was long dead, her ashes scattered across the Sierra de Guadarrama, but her final note, preserved in a margin of her notebook, found new meaning that day. We thought it came to feed, perhaps it came to listen for its reflection. And somewhere beyond the heliosphere, in the slow bloom of stars and vacuum, the echo of that chord drifted outward, a perfect mirror of what had once touched a small blue world. No one could say whether 3I Atlas had answered, or whether the universe itself had simply remembered how to sing. By the 2nd century after its passing, the name 3I Atlas had softened into myth. The data still existed, archived in crystalline memory arrays, orbiting above the moon, but the object itself had slipped from history's vocabulary, absorbed into the rhythm of ordinary cosmology. Children learned its story the way earlier generations had once spoken of comets and gods, a visitor that taught the sun to breathe. The world it left behind had changed beyond recognition, though no single generation could see the transition. The stillness, as it came to be known, was not an event but a temperament, a quiet woven into every current of energy, every field of thought. Machines no longer fought their own inefficiencies. Ecosystems balanced themselves as if following an invisible conductor. The pulse that once shook the magnetosphere had faded to a whisper, but its logic remained embedded in everything that lived and built and dreamed. Humanity learned to listen. The physicists of the resonance epoch no longer sought to conquer nature, but to harmonize with it. Power systems were designed as symphonies, reactors tuned to planetary fields, engines that murmured rather than roared. Even the languages of science changed. New mathematics built on periodicity and feedback, describing reality as vibration rather than structure. The old equations of force and vector still held, but they were now only verses in a wider song. At the University of Geneva, the Institute for Harmonic Cosmology kept a replica of Parker's Air, a small torus, polished silver, suspended in a vacuum chamber and pulsing with faint blue light. Students called it the listening ring. Every 42 seconds, it emitted a single microtone, inaudible to the ear but felt in the chest, a reminder of the rhythm that had once united planet and star. No further contact ever came. The deep space receivers listened for centuries, passing the hydrogen line and the faint murmur of the cosmic microwave background. Once or twice, analysts thought they heard a modulation, a shimmer that might have been an echo, but each time the pattern faded before confirmation. Perhaps that was mercy. The first silence had been unbearable enough. In time, scholars began to see 3I Atlas, not as an alien or machine, but as an inevitability. A principle that the universe occasionally incarnates when imbalance grows too great, the way gravity gathers into stars when dust drifts too long in chaos. It was neither savior nor scourge, but a function of cosmic self-correction. To name it was to misunderstand it. It had no will, only purpose. Still, the question lingered in every philosophical treatise, every poem, every child's bedtime story. Did it know us? When the solar observatories of the fourth millennium recorded a minute fluctuation in the sun's core temperature, a new generation of scientists revisited the data. The variation occurred precisely 42 seconds after each rotational maximum. It was small, consistent, harmless, but undeniably artificial. The sun, it seemed, had learned the rhythm too. Its heart still remembered the touch. Some called it echo, others heartbeat, and a few those who had studied the resonance equations too long, who had stared too deeply into the mathematics of coherence, whispered that it was anticipation. Because if 3I Atlas had been part of a network, if the galaxy truly breathed in cycles of harmony and correction, then the rhythm would one day return. The balance would slip again, and the silence between stars would tremble with the promise of another chord. And so humanity prepared, not with fear, but with reverence. The orbital archives kept their receivers open. Planetary power grids pulsed softly at intervals of 42 seconds, not by command, but by design, the inherited instinct of an intelligent species that had learned its place in the rhythm of creation. When night fell on the cities of Earth, faint auroras still brushed the sky, subtle veils of blue that rippled to the same eternal timing. Lovers walking beneath them sometimes felt their own hearts align with that pulse, though they could not say why. It had been written into their cells, their atoms, their music. The visitor was gone, but the pattern endured, a reminder that the universe does not speak in language or logic, but in frequency, and that every life, every star, every flare is only another verse in its endless song. And somewhere, far beyond the heliopause, perhaps drifting between the cold embers of forgotten suns, a torus of quiet light turned slowly, listening, not for worship, not for fear, but for resonance, waiting for another world to remember how to answer. The universe breathed in, and the song began again. The story ends as all cosmic stories must, not with explosion, but with exhalation. The light dims, the equations close, and what remains is rhythm, the slow, patient pulse that underlies every act of existence. In the quiet after revelation, humanity no longer asks what 3I Atlas was. Machine, organism, relic, angel, the names no longer matter. What matters is the echo it left, the gentle reminder that even chaos can be taught to hum. The sun still rises, unscarred. The earth still spins, balanced between gravity and grace. Every 42 seconds the magnetosphere quivers by an atom's width, a heartbeat of memory that no storm has yet erased. Perhaps that is enough. And if one stands beneath the stars on a windless night, when the world is asleep and the hum of technology fades, there is a moment barely perceptible when the air itself seems to vibrate. It is the same note Parker once heard before the silence, the same tone that trembled through plasma and flesh alike, the song of balance. It asks nothing, promises nothing. It simply is. A pulse carried through eons, from flare to flare, from mind to mind, teaching that everything born of light must one day learn to listen. So the universe continues, neither cruel nor kind, only aware breathing, remembering, waiting for another harmony to rise. And when that day comes, somewhere beyond the reach of language, the rhythm will find us again, soft as dawn, vast as time. Sweet dreams.